Wait, you're like asking when will it start? We're starting right now. So welcome, ladies, gentlemen, and attack helicopters. We are doing a live stream. I'm sorry I'm late. Yes, but it is live. That's the good thing, I guess. So to catch up on why I'm late. Yes, you know, German engineering. Yeah, I get the jokes. No, it's actually Chinese engineering. I'm using. Oh, okay. Now the. Hold on, I gotta mute this player. There we go. Okay. Chinese hardware. I'm using two. Why are you? What's playing? There we go. Okay. Day of technical difficulties. Chinese capture cards. I'm using two other media, HDMI to USB. I shouldn't pull on that. I just realized. USB capture things and. They're like horrible. When they work for like hours. When they don't, it takes you hours to get them going. That's the thing. So, yeah. Yeah, low res, that's coming up in a second. Just, you know, if you got any playback problems, hit refresh. I think on my side we should be good. Everything's plugged into Ethernet, so we shouldn't have any connection issues today. Hopefully audio is fine. You might hear the dryer going next door. Maybe not, maybe two. All right, so now that we have everyone in the stream, let's talk about what we're going to do today. So, I didn't set up the camera properly. It's like on my manual 90. It doesn't matter. We've got an Atom3D printer. We've got the Atom 2.0. And as announced, this thing is going to get upgraded to a Smoothieboard. This is the 4XC. I've got a 5XC in my Zabriskie board, which is off frame, unfortunately. And it's been working wonderfully there. And we're going to put this thing into that thing. So that's basically what we're doing. And we're running through the entire process of taking out the old hardware, putting in the new hardware, putting new connectors on there, putting jitter, crap. Putting, you know, wiring everything up. And then if we have time, so what we're definitely going to do is we're going to allow the Smoothieboard to control the hot and cooling fan and the part cooling fan, and the part cooling fan is going to be controlled through G-code. So your slicer will set the strength of those fans, and the Smoothieboard will turn on the hot and cooling fan once that goes over a certain temperature. That's what we're going to do. Also, the Atom has a solid state relay, an SSR in there, that you know is not really an elegant solution for switching the heated bed. So wire spools in the background are the only thing in focus. Yeah. So yeah, we're going to change that. We're actually going to use the onboard MOSFETs of the Smoothieboard because those are rated for 12 amps. Or, you know, designed for 12 amps. It's not about the MOSFET's rating, it's about how these work out as far as their resistance goes and as far as cooling goes. So that's that. What else? Yeah, we're also going to run through the Smoothie's auto calibration on deltas because it can actually calibrate for arm length. These should be relatively precisely manufactured or super precisely manufactured, but we're going to run that calibration anyways. Also bed leveling, what is it called? Delta grid leveling or squaring. Basically a very similar concept to what is that on frame? That's slight. You can just barely make out the Mark II over here. The Mark II uses mesh leveling. That's the modern version of what Smoothie has or Smoothieware has as grid leveling. So yeah, we're also going to add that to this machine. So far it's only been using yeah, it's been probing a few points, but then calculating a plane to that. So it's basically the same thing as 3-point leveling, just, you know, with a bit more resolution. I don't think it's really necessary for a glass bed like that, but we're going to enable it anyways. Okay, I am going to check focus. Is that better? Should be in focus now. But that should be better. Okay, we are also going to do some soldering today. just a bit. We're gonna add the voltage regulator. Literally just 3 pins that get soldered in, and the rest should be. Maybe we'll have to do some crimping. We'll see about that. Yeah. Hey Joe, we're not torturing the MK2 this week. It is co-staring in the background, and if you're wondering when that review is coming up, it is going to be up really soon. Not today, because I'm streaming all day today probably, but it will be up like tomorrow or so. It's a fantastic machine, you know. Expect some high praise there. All right, so why are we even doing this today? Why are we putting a smoothie board into this machine? Well, it's a combination of things. First off, I like the smoothie board. It's a great platform, but that personal preference shouldn't like influence sort of objective decisions, and that's why I have these parts right here. Let's see if my camera setup sort of works today. That would be nice. If I can. Oh, okay, now that is on. That's interesting. And that does not work. Chinese tech, why have you forsaken me? That's what I wanted to do. Okay, so I've got these hex lamp components. Thank you, Vinny. I can't actually read that. I should pull up the other tab here. Thank you for the donation. Always appreciate it. Let me just grab the note that came with that. Why are we doing this today? So I've got this overhead camera which has autofocus, so you guys can't complain about focus or not. And you can see these sort of patterns on the print, right? I guess it's this side, right over here. And they are extremely regular. I mean, it's also sort of wavy, and the print stopped. That was my fault. But you can sort of see these patterns. I was thinking these were over extrusion artifacts, but the fact that they are so regular and even appear when I turn down the extrusion multiplier and appear on several prints exactly the same. So this one has the exact same artifacts. I just checked them against each other, and this side is actually the worst. That makes me think that it's actually a thing where the relatively underpowered 8-bit hardware sort of runs out of processing power and has to make too many approximations. So for a Delta, you got all 3 motors that need to be precisely controlled, and you can't just say, okay, if you move from point A to point B like this, each motor is going to move in a linear or at a constant speed in a linear way. You actually have each motor going at a, what is it? It's like a non-constant speed, and the more points you have along that curve, the more accurate your prints are going to come out. So that's where the 32-bit 72 megahertz, I believe. The 72 megahertz processor, also 32-bit, so it can do a whole lot more calculations in a single clock cycle, plus it also has a lot more clock cycles versus the 16 megahertz processor in there. So there's the big factor for Delta machines why we're doing this. Now the other thing we are doing for this machine is we're giving it Ethernet capabilities. So you could go ahead and use an element. Actually, we demonstrated that 2 weeks? It was 2 weeks ago. We used the element to actually control this exact Atom3D 2.0 over Wi-Fi, over network, or you could use a Raspberry Pi and connect it, but that's additional hardware. The element is like $200. The Raspberry Pi is still 35 plus Wi-Fi hardware plus all that. So yeah, having that integrated on here, it doesn't give you Wi-Fi yet. 120 megahertz. Okay, I got that wrong. Sorry about that. We do get an Ethernet port right here on the Smoothieboard, which is a bit more than just the mechanical plug. I believe you can buy it without the port, which makes it a bit cheaper, but this one has it on here, so we can just plug in a regular Ethernet cord or a Wi-Fi bridge or whatever else and get basically full remote control over the machine. Also has an SD card, built in. So this, the way that the Smoothieboard handles this is actually kind of interesting, because you do have the regular micro SD. Where's our focus? There's our focus. You do have the micro SD card that stores your print files, obviously, and the processor reads directly off of that. But it also stores configuration and firmware updates. So if you want to do a firmware update, you put the new firmware on here, and it automatically updates that. So that's sort of cool. And of course, you also get to access the SD card over Wi-Fi. You can upload files with the interface that's directly served from the processor. So if you just hook this up to Ethernet, you're directly getting like a very basic move X, Y, or upload a file and print or pause and that sort of stuff interface. But if you have the time today, we are also going to add an Android tablet to the machine. So by the way, Arthur Wolf, the guy making the smoothie board, sent me the tablet and the hardware and all that. So huge thanks for that. And the tablet he sent me is like a super cheap Lenovo. I don't want to no problem with cheaping out there. It works. You don't need anything special there. This is like a $69 or something, or $59 Android tablet. It runs Android 4.4, and basically all you need is a web browser, and this will have a web-based, so an internet-based interface that then controls your local smoothie board. So either use the Fabrica or Fabrica, no idea how to pronounce that, interface, which adds a nicer interface on top of what the smoothie board serves itself, or you can directly use that interface that the smoothie board gives you. Right. Yeah, so that's going to be our controller, or our LCD interface. Basically have the Android tablet, touchscreen and all. And yeah, if we have the time for that, we will be looking into how we're going to set that up. So I don't know how well the Wi-Fi works down here. Let's just check what the tablet is saying. Oh, full reception. Okay. We should be... Wow, sorry about that. We should be fine. So timing for today's live stream. There is the Patreon hangout at 8 p.m. my local time, which is in 4.5 hours. So that's all the time we're going to have today. So is it 4.5? I suck at math. It's 6.5 hours. So 6.5 hours is the time limit for today, where I'm going to miss that Patreon hangout, which I really don't want to do because I really appreciate every Patreon that supports this channel. All right. So I've actually got Arthur Wolf with me in a Google Docs document where we kind of planned out what we need to do to convert this. If you want to follow along, there is the Smoothie Wiki. There's the Smoothieware Wiki at, I don't know, Google it, or Arthur can post the URL, where you can find all the instructions for every step we're going to do, as far as the actual smoothie board configuration goes. So you're going to find wiring diagrams for which heater goes to which output. You're going to find firmware instructions for how to set up the Z probe, which this printer has. It pushes up the hot end and then actually uses that motion. Let's just get that into frame because the other camera is blocking that. Maybe you can see that it's actually lifting the hot end up and then clicking a micro switch as that touches the bed. We're going to set that up, and of course, you follow along online for all that good fun. All right. Let's get going. So first things first. So what we need to do first is, because we have a printer that is, mechanically accurately built, not like the Zabriskie Reborn that is like, let me just see if the webcam works, so I can bring that in frame and give you like a quick comparison. Why work? Is that? Oh, that's why. That's why. Okay. That explains it. Do I have like a USB port somewhere? I guess not. Well, I guess I'm not going to be using the webcam. Anyways, the Zabriskie Reborn is kind of a lot less accurately built than this one. It doesn't have the rods at very exact lengths, so I actually trusted the Smoothie auto calibration to use or to automatically detect how long these rods are, because it can do that. It relies on the bed being sort of flat, kind of mostly flat, which this one and the other one is, and then it automatically calculates how long these rods are, which works perfectly, by the way. So, yeah, let's get the, that's the fan MOSFET, okay. Let's get the configuration parameters that we can already pull out of the machine and just like note them somewhere. So we're gonna have the one thing that we need to get from this machine as it is before we disassemble it is the Z probe offset. We can set that while it's, you know, all set up and stuff, but yeah, it's just easy to grab that value right now. So that's gonna be something we can grab from the LCD, and I think if we get to go to the top camera, that should be visible for all of you. So as far as noise level goes, because Chad was asking that topic, so that's the hot end fan right here. That's always spinning on the Atom. And that's that. There is a larger fan in the electronics compartment, but that one isn't all that noisy. And for actual operation, it is kind of okay. I actually have a decibel measurement in the review video. So if you want to know the exact reference there, go check that out and have a look there. So what we want to do is setting Z offset, and there we go, Z offset plus 380 micron, 380 microns. So basically there we go, basically the hot end, the point where the switch triggers as we press that up is 380 microns below the bed surface. So the second the probe triggers, we're actually inside the bed already. So for the Z0 level, the hot end will have to move up the 380 microns to actually, you know, be level, and then move up whatever your first layer thickness is to get that layer on there. Well, all right, that's that. Perfect. 380. Now, thankfully, because that's it. By the way, that's a good power supply. That's a Meanwell one in here. Huge capacitors. Thankfully, because, you know, even though the Atom hardware isn't open source completely, you know, you can download the effector file. It is still running a regular copy of Marlin, and you can download that entire source code, which I did, and we are going to look into that in a second once we get into the firmware configuration. But first, let's do hardware. And I guess we're just going to start with taking this entire thing apart. Now, the good thing about the Atom is well, I guess other than the fact that the firmware is open source, it is actually built in a way where you can just reach in and pull the electronics out. It's all below this top level of electronics, or top level of heated bed, aluminum plate right there, and this is just screwed to this top vertex, this top triangle, and relatively easy to take out. So we need a 2.5mm hex key and the 2mm hex key for these right here. Does Marlin forbid using it on closed sourced hardware? The thing is, it is still, I think it's GPL licensed. The wording on the Marlin page is like, please do not use this hardware, this firmware on hardware that is closed sourced or crippled by patents or that. But that is more like a, hey, you know, if you want to be cool and stuff, just, you know, don't do that. It's not legally binding. It is still licensed under GPL, so that basically means you can use it on whatever hardware you want, as long as, you know, you keep those GPL details intact. Keep you from what is it, combining the code with proprietary closed source code. I'm no programmer. I don't know all the exact technical details, but the GPL, technically speaking, really isn't that restrictive as far as what sort of hardware you can use it on. Yeah, so workflow, networked versus non-networked. My personal preferences as far as usability, as far as how much I will use a 3D printer if it has solution X on there, is like, if it only has USB, I have to sacrifice my laptop for the entire time the machine is working. Which is, yeah, sort of, yeah. I mean, I did that for a good while, it works, but I sort of like, I do like using my laptop like outdoors, writing scripts and doing that sort of stuff. So I guess that is like the very basic, very most basic version you can have of any sort of 3D printer control. Next up is SD cards. Do sort of work out well. However, I do still need to move my lazy butt down to the 3D printer and actually insert an SD card and remove that, and updating files, just quickly reslicing something is still sort of tedious. Yep, those are the aluminum standoffs. Just quickly changing a G code is still sort of tedious, but it sort of works as well. It's like a good intermediary, low cost, no cost solution. But of course, having the 3D printer networked, particularly with how Slicer or Slick3R integrates into Octoprint these days, where you just instead of exporting G-code to a local file, you just hit upload to Octoprint. Once you set that up, that is like heavenly to use. So if you're using Octoprint and if you're using Slick3R, definitely check that out and set that up, because that's going to make your printing experience a whole lot easier and more comfortable. Don't drop a screw inside the power supply. The power supply is actually, if we switch over here, let me grab that cheap ball head and actually tilt that in here so you guys can see something. There we go. So you can't really see that much, but the cool thing about the Smoothieboard is you have the solid state relay is over here. You have the entire control board up in this compartment, and the power supply is actually below this one, which means you can't really mess up all that much. So while everything is still plugged in, let me think, do we need to take notes for anything? Not really. Not really. The things that are basically self-explanatory are the motors, which I'm going to talk about in a second. The heaters are sort of self-explanatory, plus the thermistor for the heated bed. We can just easily track the wires, which should be these two. And then these two yellow ones are the thermistor for the hot end. So as end stops goes, the end stops just come out the pillars that they are connected to, so that's all perfect there. And yeah, motors got that sorted out, power in. So yeah, I guess just take out everything that we don't need. We've got this one USB cord that is the same USB type B that we can reuse for the Smoothieboard. No problem. All right, over here. I think I'm gonna have to quickly make this thing a bit brighter. Auto ISO. There we go. Okay. So the board in here is just held in with these nylon standoffs. These are just like spring-loaded. Ooh, that wobbliness. This has like spring-loaded little couplers that hold the board in. Before we take those out, let's just get everything out of here. And yeah, motors obvious. Then these over here are the two fans. This is that one fan over here, the one electronics cooling fan. I don't think we're going to be needing that for the smoothie board. Mostly because this is just better hardware. Just as simple as that sounds. But the drivers on here have little heat sinks on them. That's like the main reason the fan is on here, I guess. On the smoothie board, there are the... Are these the... Okay, so it's the same package drivers as these over here, which is like TSSOP... Wow, 24? I have no idea. Can't count. And these are actually cooled into the board. So if you look on the bottom here, if you look into the reflections, right there you can see the vias, or whatever they're pronounced in English. These are basically small copper tubes that connect the electrical layer from the top and bottom, and not only transfer current, but also transfer heat from the package to the large copper base on here. So these chips, they are plastic on top, and plastic is a super bad heat conductor, but they have a huge exposed metal pad on their bottom, which gets soldered to those vias, and then basically allows the chip inside this package to transfer its heat as efficiently as possible into the board area over here. So ideally, if you want to cool these, you'd put a heatsink on the bottom, not on the plastic top, because plastic is an insulator, and the copper on the bottom here is a much better heat conductor. So I don't think we're going to be needing this fan. Plus the other thing is, these are decent MOSFETs. These are like MOSFETs that are actually rated for what they say on the spec sheet. And the fact that this MKS based hardware, the fact that this MKS based hardware needs the extra solid state relay to even drive the heated bed is just due to this MOSFET not being good enough to drive that heated bed, which the smoothie board's MOSFET should be. Okay, so this connector over here, this is the Y pillar end stop. I already messed up the connector on this one and had to crimp, or these are the original ones. I had to take out the plastic casing of that connector and just use them bare. Arthur, no problem. We are fine here. Okay, that's the thermistors coming out. Perfect. Yeah, so this one is also naked, just because I sort of I mangled them while assembling this 3D printer. So if you want to check out that recording of how this Atom was assembled, you can do that. It's up on my regular YouTube channel. I'm going to grab a screwdriver. Actually, there's one over here, which is perfect. Since, power in over here. There we go. Then we've got, what's this? I believe that is a heater output. We're going to look into that in a second. And then fans, part cooling fan, as well as, what's this one? Well, I guess we're just going to try it out. So this one doesn't have polarity, so it's a, what? It's a heater? And the other thing is the wire colors in the Atom are sort of non-standard. So the colors we have on here are actually what we use in Germany for mains wiring. So we've got the neutral and hot phase over here, but these are actually 12 volts, and the wires that go into the power supply are red and black, which totally doesn't make sense. Can we wire up this LCD to the smoothie board? yes, you could, but you'd have to use an Arduino-based adapter, because this is apparently a parallel LCD or a or an LCD that is relatively slow to control, which is why it slows down if the machine is printing so much. Why it slows down so much while the machine is printing. And you can use an Arduino-based adapter, which basically just emulates what the Arduino on here does, and takes instructions through, I don't know, I2C, SPI, some sort of bus that's a bit faster than the LCD's own interface. Now the thing with the Atom 2.0 is I can't mangle this printer too much. I still need to do an update review with it. There will be an Atom 2.5 that I'm going to get the upgrade kit for, which basically transforms this machine into the 2.5. So it should be somewhat original, other than the hardware, which obviously we can just easily replace, take out, and put back in. Right, that is done. Now, let's see. End stops over here. Those, do those fit? That's the question. So we've got plus, minus, and the output. So these could maybe. Oh yeah, look at that. We can just jam those on here. No problem. That's sort of cool. So these are different connectors. Sorry about the camera shaking and not focusing. There we go. So these are different sort of connectors. So these connectors are the what's typically used for computer fans, 3-pin PC fans. But these other sort of locking connectors also slide on here kind of okay. I mean, they bend the flap away, but they make good contact. They are both 2.54 millimeter or 1/10 inch connectors. And yeah, that basically makes them sort of compatible. We could break the flap over here and just remove that to leave it with the pins, with only the pins itself. The only thing that might be tricky is jamming in the Z min, which is this one over here, the Z minimum switch, because it's so close to the other two. You might have to shave a bit off this connector or take it out of the casing. All right, Tom couldn't fry sausages. Yeah, unfortunately, and that sort of went south pretty quickly. Now that works. We got that figured out. End stops we can connect. Now fans. This is the hot end heater. This is a power input. I think I'm gonna have to open up the bottom of this printer as well and just have a look at how the power supply's wires come up here. Let's get that in focus again, because I really don't sort of want to. No, these are the power cooling fans. Obviously, I sort of don't want to break anything, especially now when it comes to the fans. These are fairly special. Let's see if we can focus. Come on. I should have used point focus. There we go. These are actually pretty cool part cooling fans. They are. Stop shaking. They're flat radial fans that actually suck in from the sides and then blow out the bottom, which makes them really sort of nice and compact, but also sort of hard to replace, unfortunately. Okay, now mounting the smoothie board. So space-wise, we're good. That fits. That totally fits in there. Absolutely no problem. We might have to look into how we can. Yeah, so I sort of don't want these connectors going into the fan. You know what? I'm just gonna take out this fan because honestly, I don't think we're gonna need it. It might get sort of warm in here, but that should be okay. Let me just get some wire cutters to cut that off. Also grab some wire strippers just to be safe. So this fan is going bye-bye completely. Bye-bye. Now the power supply is on the bottom here, but it's not connected to this exact acrylic plate. So we should be good drilling through here. Let me just feel around for this. Yeah, so there is about a centimeter of air between the... Wait, what? Ah, that's it. Okay. Yeah, so there's about a centimeter of air below this acrylic plate before we drill into the power supply. So I guess we can just adapt the mounting spots for that. It's not plugged in, so even if we drill through the mean wheel power supply, it's not going to be that that shocking to see. Yeah, as far as the LCD goes, so my plan basically is get that off of here. I do not really want to take this up because we'd have to disassemble the entire lower frame of the machine. We basically have to take this entire bottom frame extender off. That is shaking again. So what I'm going to do is I just pulled off that that knob for this. I'm going to put a spacer on top of here, use this aluminum casing. How annoying is that shaking? Let me know. I'm just going to put a spacer on between here, fix that to this aluminum bracket, and then put the tablet on like this. And that actually looks like, I think that actually looks like it belongs there. That works pretty well. The glass bed is going to sit somewhere around here, so that's going to be slightly sticking out. So I do have to be careful not to have that touching, because, you know, tablets don't like heat that much. But yeah, that's the plan. Just put a space in between here and use that as support directly. That's going to be just a piece of wood or something like that. You're not going to see it in your regular use, so it's not going to be a problem. Oh wow, these are tight, but they do come out in one piece, which is great. So connectivity, oh, come on. As far as the atoms and the Smoothieboard's connectivity goes, the MKS based board uses these screw clamps where you basically screw in a wire directly without any sort of detachability. Camera, come on. Without any sort of detachability, they're basically a four block, and then two blocks that stack together, and you basically screw in your wires directly into the board. The Smoothie board has these detachable connectors. I think these are like brand name ones. I don't know the exact brand, what they typically are or what they're typically called, but they work in much of the same way. The only thing is, instead of screwing directly into the board, you get, wait for it, we got the accessories bag here. You get these detachable, there we go. There we go. You get these detachable screw clamps, which have the same sort of connector in the back here, and basically plug these in right there. There we go. And that's the same as that. Basically, if you want to take the board out, if you want to replace the board, do something else, you don't have to unscrew everything and, you know, fray your wires even more than they already are. You just leave the connector on there and plug it in and remove it. Awesome. All right, let's get that board in the Atom itself. I don't know, I feel like putting the camera on that long boom is sort of was sort of a bad idea. But oh well. Oops, there goes the zip tie. I'll just fish that out. Nope. There we go. Okay, so the Smoothie has a few different mounting options. It's got one hole, two holes over there, It's got one down in here, which probably isn't much use because the connectors all around it are so tight. Let's just try a regular M3 screw and drop it in here. That's probably too short. Okay, so that actually does fit. That actually fits in there pretty well. So we can use that one. Then we've got another one over here. That one also fits. And then two more right over here. These look like they belong to the connectors right there, but they are sort of independent from them and you can just use them as screw holes. So I think I'm going to be using, since there's going to be a lot of plugging in and removing action going on over here, I'm going to be using this hole, that one, and I don't know, this one. Since we only have the 4 standoffs, that's going to be what we'll have to make do with. And ideally, I kind of want to reuse 1 or 2 holes there. Wait. First of all, let me just check if these even fit. Oh, well. Huh? Okay, so these do fit. It's a really tight fit, but you can get them in there. That works. Yeah, Arthur, I'm reading you. So one thing we need to do first, before we actually mount it in there, I'm going to drill the mounting holes first and then do this because we're already at it. We're going to add the voltage regulator, which is a 24 volt or 28 volt, up to 28 volt to 5 volt switch mode power regulator. So it's like an LM7805, but way more efficient and with a way larger input range. And we're going to drop that in here, solder that in, and also add diodes to the fan outputs, which we can add, I guess, to the solder points right there, just to take a bit of a load off the MOSFETs. I don't think we actually need them, but you know, just to make the MOSFET's life a bit easier. Otherwise, you know, fans and motors, because they are inductive loads to a certain extent, they charge up with current as they start spinning, and then when you take the power away from them, they actually keep that. They want to maintain that current, and worst case, apply a voltage spike to your MOSFET that destroys the MOSFET over time or wears it out, or, you know, worst case, if you have like a big inductor or motor or something, it blows the MOSFET off the board immediately. I've seen that. It's not funny. Typically, like extra safety measures. All right, mounting points. We are going to need a silver. Do I already have this here? Yeah, there we go. We're going to need a silver pen. By the way, if you don't have one of these are awesome. Why? Because silver ink is visible on black stuff like this. You're not going to be able to mark anything with a regular Sharpie or something, because it would be black on black and completely invisible. That's why you use silver or white. White pens also work for that. Let me just see. So we've got the input panel over here. There's the USB. The USB is sort of short. And I guess we could plug that. Wow, that is actually pretty tight. So it looks like we'll have to orient this like that, which also works. But then we're gonna. That's the. Okay, that's the control line to the solid state relay. We're actually not going to be using that. I might have to add a longer wire right there, which shouldn't be a problem. Yeah, see, the problem is that the USB is sort of short, and the only one we're going to be able to reach is over here. Let's see, right there. Like slightly over here, so that we don't overstress the USB and also get some space to plug stuff in over here. The connections on this other side plug in straight from the top, so that should be fine. Does that sound good? over here. Did that go through? Nope. By the way, quick tip, if you do not have a pen that is long enough, just make like a little cross on the outside. And that will allow you to see where you want to drill your holes afterwards and align them properly. Okay. 1, 2, 3, and this one is. And because we are using those nylon standoffs, it doesn't have to be super precise, but you know, just sort of in the right direction should be okay. Right. Drilling. Let's get some holes in here. So ideally we want to use the same size as we're using for the as were used for the original nylon standoffs. This looks like a 4-ish millimeter one. Might actually be slightly larger, but because this is acrylic, it's better to drill twice and widen up that original hole instead of drilling once and tearing the entire acrylic up in the first try. So let me get a cordless drill. I thought I just had one, but it disappeared. Also, to catch up from on the donation from Vincent Braxhoven. Braxhoven. Thanks for fixing the focus. That was the donation right at the start of the stream. That is very generous of you. Thank you for that. And as always, donations are appreciated. You can find the links in the video description. They are going to show up on stream as a popover for everyone. Okay, there's no power supply on this one, so we're fine there. That's also good. By the way, I checked. There is like a solid aluminum part of the power supply underneath that, so we're not going to drill right into the supply. You know, it's going to stop it before doing any real harm. Okay, let's see if these fit. Perfect. All right. Oh, that actually looks like it's supposed to be for that. And that's our hole right there. And we should be able to plug the smoothie right in. I'm not going to plug it in all the way yet because I need to solder those diodes and the voltage regulator first, just checking for positioning. That looks good. Come on. 1, 2. Ooh, okay, that's a problem. Seeing now that we are further up, this is actually colliding with the motor over here. Okay. So I guess we need to move all these a bit further over. So that's always something you sort of need to check for. These do have a certain length. Keep that in mind when aligning things. Wow, and these are like super tight right now. Don't think we're going to be able to use these too often, but should be often enough for our purposes here. Unless I break this one. There we go. All right. Okay, let's do that re-drilling in a second. Get the smoothie board prepared first. That we are not going to need. Actually, so So what my plans are with the Atom3D are two different ones. So first off, the smoothie board, obviously putting that in there and seeing what sort of a difference it makes. That's part one. The other part is going to be trying to replace the stepper drivers on here and trying to see how much of a difference something like the silent step sticks make. Because these are, after all, still the classic, let's connect this, the classic Lego drivers. And I am going to put some of the silent step sticks, the dynamic base drivers on there, which also, which also are cooled from the bottom and fit on like this basically, and they are much finer as far as the microstepping goes, and also much more accurate as far as their actual control schemes go. So that should make a difference in the stepper resolution. I have no idea how much load it is actually going to take off the board, if any. But yeah, just something to experiment with. All right, soldering. Let's get it going. So let's pull that in a bit further. Soldering. Now, soldering is something everyone should be able to do, should know about, and how to approach. It's a really helpful skill to have. If you've got the money, buy like a soldering station. Super useful stuff. But if you can get just like a plug-in soldering iron, that does work as well. Just get something that sort of has some mass at the top. Not just like a needle or those pistol grip type soldering irons. Those aren't what you want to use. You want to get something that has like a solid iron or copper tip. And then yeah, technique is not that hard to figure out. You do need some good solder. That's always that's like one of the main things. I'm using some German lead-free, acid-free, non-corrosive, no clean solder. This stuff is awesome. I know a lot of people say, oh, you gotta use leaded solder. I would completely disagree with that. I've been soldering with lead-free solder for years and I'm loving it. I don't see any sort of performance difference. So there is still that very valid health concern, which is why I'm not using leaded solder at all. And yeah, I've been very happy with the lead-free solder, as long as you get a decent brand and not just the cheapest stuff and that you can find somewhere on Amazon or somewhere else. Really buy decent solder. That makes a huge difference. I've used cheap solder before and it ate up my my soldering iron tips like no time. Like have a quarter of a spool and there would be a huge hole in the tip. Thankfully this one doesn't do that. So what I've done here already is I've inserted the regulator. Now the little legs came through and actually bent them in opposite directions, so it's locked in place. It's not going to move anywhere. Otherwise I'd have to hold it with a finger from the rear and actually keep it in there. So now it's all in place. I don't have to worry about a thing. And basically the one thing you want to do is you want to heat up your pad and the leg and then apply the actual solder that's going to hold everything together. So first off, let's clean off the tip because that has some dirt on there. Some people like to use like paper towels or stuff. That also works. I just like to scrape it off with a knife, and that will take everything off without burning anything. Water is bad for tips. Water will actually cool it, give the tip a thermal shock and degrade it, so don't use that. So what I like to do is actually apply a bit of solder before just to give it a better thermal contact, then heat up the pad and the leg, and then add the actual solder to those two. And you want to remove it once you see the solder flowing to the pad. So that's a good solder joint right there. I'll zoom in a bit further just to give you a even better look. So okay. So that might already be a bit too much solder, but yeah, for this sort of thing, it should be fine. So heat up both the pad and the leg, then add solder, wait for it to flow, and there we go. And often I see people just like you know, putting a bit of solder on the leg like that, or you know, so that it's just barely touching the pad below it, and that, I mean, it looks good, it might work, but it's a definitive cause for issues down the road, because that doesn't make good contact in the long run. There we go, we just saw that solder jumping, and I often like to go in and just clean that up a bit. And there we go. 3 good solder joints right there. Perfect. And that one isn't going anywhere as well. So, don't get solder chips on the board. Yes, that is a good suggestion. You know, little balls that might fall off. Don't let them run around. However, the backside here is pretty good on that regard, because there's not much where it can get caught. Diodes, yes. Next thing. So free run diodes, which are basically, camera still shaking. Yes. Do I have diodes here? Nope. I think I'm just gonna grab some Schottky diodes. Basically, they let the where do we solder these in? So those should basically go from the plus side of the power output to your supply plus, which means like here we got the plus and the plus, and we can just route those on the bottom, I suppose. So yeah, basically from, and you know, some boards have those built in, some don't. Like I said, they're probably not strictly necessary, but we're just going to take a Schottky diode and place it from the positive side. Oh wait, not from the, hold on. Positive side is positive anyway, so we're going to route those from the negative side, which is the switching side of the MOSFET, right there, and route that to positive. So basically just from there to there, and wired in a way where it where it doesn't conduct in regular use, because you just short out the MOSFET basically, but in a way where they're normally in a non-conductive state, and only when that MOSFET turns off and you get that inductive spike, they actually allow that spike to flow back into the supply voltage instead of having to go through the MOSFET. Which means I'll grab some Schottky diodes. Right there. So these are, what are these? These might be 540s, I have no idea. They're Schottky diodes. They're a bit thicker than your usual rectifying diodes. The 1N4007, those are not Schottkys, those are just regular silicium diodes. These are Schottky diodes, so metal on silicone. So that's the word I was looking for. So 2 of these. Quick tip with working with, like, it's called bandits or these strip mounted devices. They're always going to leave some glue on the end, so don't use those ends. They are going to have that filth on there that makes soldering really hard. Snip it off, and even if you just push it through the holes, just cut them off. You don't want that messing with your solder joints. So these will go with the stripes. So that's the basically flow direction on diodes. If you have the technical current or technical electrical direction is from the non-marked side to the marked side. So if you apply a positive voltage to this and a lower voltage or a negative voltage to this, then there's going to be current flowing. If you do it the other way around, you're not going to get any current. So basically what we want to do is add them to these small outputs. These two small outputs over here. That's the input, that's the output. Chicken, yep. And have it, you know, with the marked side going towards positive and the non-marked side going towards negative. So sort of like that, and then insert them right here. There we go. And I'm not sure if these through holes are actually made for adding diodes, or if they are just an alternative spot to solder a connector, but I mean they work for that, so why not use it like that. Yeah, why did the board not come with SMD or SMT diodes in place? That is a good question, because those diodes are literally like dirt cheap. I don't. Like I said, they are not strictly necessary. They're like optional, few good things you put on there. You can get away without them, but you put them in there just to be safe. I like to trim these beforehand, just because they have a lot of thermal mass, these legs that poke out. I'm going to trim these flush afterwards, but just for now, to keep the thermal mass low, taking a bit of material off before we go in and solder them on. Come on. There you go. And same thing as before, we want to heat up the pad and the leg first, and then wait for the solder to actually flow to the pad. There we go. And because these are gold plated pads, we don't need any sort of flux or acid cleaner or stuff like that before, because the gold does not corrode. We can just solder it straight onto it. I do have a flux pen right here, just in case we need it. Hoping my head isn't in the way there. Okay, so that one will need a bit, a bit more time to heat up. I'm just backing up right now, not to overheat anything. Now the thing is, with these big planes, if you look at these, that gold pad is actually directly connected to this entire copper area all around it, as is this one. So you're basically heating up that entire copper section right there. And like I said, if you have like one of those gun type soldering irons that have only the tip that heats up and no actual thermal mass, you aren't gonna have enough mass to completely heat that up in one go. And instead it's just gonna try to heat up and heat up and heat up, and it's gonna heat up the entire area instead of just that spot you want to solder. Clean the solder iron tip. That's clean enough. I just turned it up a bit in heat, and I am going to add some flux, even though I say we didn't need it, but you know, just to be safe, that might have been a bit much. Where is my... There's a good rag. There you go. All right, so that's I've turned up the soldering iron a bit, so it's on 450 degrees Celsius, but that reading is a good bit off. So come on, come on. Wow, that is sucking away a lot of heat. It looks like we got a connection down here. But what I'm actually going to do is I'm going to swap in a larger tip. That is just one of the advantages of having a soldering station. Where is the surface where I can put this glass? There we I'm just going to swap in a larger tip and try and solder with that. There we go. That's still hot, okay. So that one should have a bit more thermal mass, just to heat it up a bit faster, just not to have to rely on the heater actually heating up, but on the thermal mass of the tip right there to transfer all its heat into the board. And yeah. Lead-free sucks, too brittle on boards that flex slightly with heat, which is why the Xbox 360 had the problems it did. The thing with boards that flex with heat or without heat is it's typically not the solder that breaks, it's the capacitors that break. Might have been the solder in the Xbox 360, but if you have boards that are subject to mechanical stress, you sort of want to look into capacitors first before you go into looking at your solder. Wow, this doesn't look elegant at all. Come on. Come on. It's still not heated up. Yeah, and that's it. The other thing with lead-free, lead-free takes more heat to melt, so it's not as easy to float. Those are not good solder joints. So it takes more time to flow to pads like that, to bigger ones. You know, there are a few techniques you can use to make that easier for just the solder to flow, which is to use the, what are they called, thermals? I just know them as thermals, basically little connecting pieces or little connecting parts on the actual pads. I think the Smoothieboard does have them somewhere, and basically they break up that large connection to the pad. Let's try that again. What can also help is to heat up the board beforehand with a hot air gun, just, you know, not to melt the solder directly, but to give it a bit of an edge when it comes to how much heat is actually going to need to be transferred into the pad to melt everything. Wow. This is literally not going anywhere. That is amazing. So kudos to using like lots of copper in there, but maybe some thermals in there would be nice. Like that again. I will open up the window after this. Don't worry. Pin on there. Oh, and with the flux, you can actually see that there's like no solder stuck to the pad yet. Okay. That looks like it's at least, yeah, that's actually on there, at least for half the pad, which is better than nothing. And this one might be a cold joint, which we kind of don't want, so let's heat up that one again as well. You had no problems at all soldering the diodes on yours? Well, you know, live, stress. Oh, look at that. Wow. Hoping that's the same pad. It does look like it. Let's break that up. There we go. Okay. Got that done. Jenny solder looks better. Yes, I know. I am going to open up the window real quick. Here we go. Got that done. Okay, diodes are in. That wasn't hard at all. Let's get that out of the way over here. So, and even if these painful, I don't know why this one isn't soldering that well. Usually I have no problem soldering stuff, and I did solder lots and lots of joints already, but this one just, I don't know, doesn't want to come together. And usually with this soldering station, I don't have, you know, that sort of oh, there's a sticky end. That's sort of an issue getting enough thermals or thermal energy into the joint either. I don't know. I blame it on the cameras. I blame it on that camera and on that camera. So yeah, right. Lots of heat sinking. Yeah, that's good for the components, but bad for soldering. At least for like manual soldering like that. Okay, let's move forward. Let's move on. So as we figured out just a second ago, this one does not fit. The mounts we drilled were off. They aren't in the right spot. 1, 2, there we go. I'm gonna stop shaking. There we go. So we need the USB back here, and then we need the other parts right there. Let's see how big these connectors are going to be. So there are a few crimp, crimp connectors included with the Smoothieboard. There's actually an entire row of the regular white ones. And these are just gold-plated ones for the DuPont style connector. So if you want to crimp that yourself, you can do that. You can either use you know, a proper crimping tool, which I'd recommend, or solder them in, which you can also do, but is like painful to do, and typically has you ending up with connections that don't fit the plastic parts. So this one, let's just pop these in and see how much they add as far as length goes. Go on there. So these two are the outputs, and that third one over here is the power input. Let's see if we have the USB cord over here. And then if this one gets lifted up, that should work a lot better. Okay, let's try that again. Okay. Okay, and where is this one over here? Okay. I'm hoping this silver ink isn't conductive, but I don't know. Probably not going to be. And there. Right. Route the USB below the stepper. I just realized I probably shouldn't be. I shouldn't be resting my hands against these aluminum profiles, because they are sort of sharp. That was from yesterday. That's like from now. They're always sort of, yeah. As you can see, The shell does have some sharp edges, which isn't that great for like skin and stuff if you rub it against it. Route the USB below the stepper. Let me see. Oh wow, that is extremely tight. It could work. Could work. I might do it like that, but it is. I just want to point out it is extremely tight. But it. Oh, we can. Oh, there we go. We can actually have it go into the spot in the back here. Perfect. That, and the last one over here. Ow. Up here, okay. Silver is usually conductive though. Yeah, if this eating glass, metal, plastic, paper marker is actually conductive silver or conductive ink, then that would be pretty sweet actually, because you could use it for like drawing circuits. However, I think it is just like aluminum with typically it's like aluminum powder that is coated in like a plastic something. It's like a really fine metal powder, yes, aluminum, but typically non-conductive though. Yeah, grab the multimeter and find out. That I might actually do that. 1, 2, 3, and then this one up here. So what I'm just quickly going to do is I'm going to remove the or actually unscrew the heated bed, because it is getting in my way, and I don't want to have it dangling around. Yeah, well, let's see, but we can set it down flat over here anyways, so that should be good. This one goes over here. Now the wires for the LCD, I'll just tuck in the compartment somewhere, and I am going to leave the LCD in place, just so that I don't have to take it out. And just to be honest with you guys, this is a lot more elegant than how I installed the Smoothieboard in the Zabriskie board. Because this is getting like standoffs and like proper mounts and stuff, and the Zabriskie board does also have like a center plate like this, but that center plate is also the carrier plate for the heated bed, so it basically only has this plate right here, where the heated bed sits on top, and then everything is mounted to the bottom of this, which works, makes it like really slim, but also makes it like really crazy chaotic to wire up and to mount new things to. All right, got that in. That is actually looking pretty good. It looks like it's supposed to go in there. Yeah, we do not need the SSR with the smoothie. We could just throw it out. I'm still thinking about whether I'm going to throw it out or not. I don't know, because we might have to go in here and rewire some stuff that's coming from the bottom compartment. Let's just do the other things first. And in fact, let's look into how the motors here are going to be wired up. So we've got 4 motor outputs on this Smoothieboard 4XC. It's a which is like the mid-level model. You can get the 3 motor output for CNC machines, X, Y, and Z. You can get the 4 motor output for a single extruder 3D printer. So you've got 1, 2, 3 motors for linear motion, and then the extruder as the 4th axis. Or you can get the 5X or 5XC which has 5 stepper drivers for dual extruder or other contraptions that need 5 stepper outputs. Now typically those outputs are labeled X, Y, and Z, and so they are on the original board that came with the Atom. There we go. So that's X, Y, Z, E0, and E1. Now, obviously, that is made for a Cartesian machine where you have directly, if you directly have, what was I going to say? If you have a Cartesian machine where you have an x-axis, a y-axis, and a z-axis that directly corresponds with the motors that you're using, and then that nomenclature, that name XYZ makes sense. In this case, it doesn't. And the Smoothieboard actually does not have those. Where am I? There am I. The Smoothieboard does not have those designations XYZ. It's simply calling its which way to push it? That way. It's simply calling its outputs M1, M2, M3, M4, and M5. So for an Cartesian machine, that would basically mean X, Y, Z, and E. For a delta machine, that means alpha, beta, gamma, and so on. So yeah, so basically we need to translate those motor outputs to what these pillars work out to. So the way the Smoothieboard works out is, here you go. Basically, this is what's typically X, this is what's typically Y, and this is what works out as Z. Or you could call this alpha, beta, and gamma. How do you draw a gamma? Like, why is that? It's like, it's gamma. What, like there. There's a that looks like gamma, sort of. Alpha, beta, gamma, which you cannot see because whoops. There is an effector in the way. There we go. X, Y, Z, so alpha, beta, gamma right there. And that's going to be the names that are going to be used in... that's the names that are going to be used for the firmware configuration as well as for everything else. That's going to be going on with the... with calibration as far as, z-axis offsets and stuff goes. That's going to be the names that are referred to, and this gamma, I believe, is like the reference for z-axis height as well for Smoothie. So basically, the way these are being hooked up, again, these are not the exact connectors that are supposed to be used for this sort of a looks good for this sort of a flap-based PC fan connector. But they fit anyways, so let's just get them in there. I'm too lazy to recrimp them. They're offset, so we are going to use it like this. And if they turn the wrong way, we can always just reverse the direction in firmware, which is much easier to do than crimping new connectors onto these. There we go. People bothering Joe for discounts. It's like a recurring theme. People bothering others for free stuff or discounts. It's like, hey, give me something special. I want to feel special. Hey, Angus is here. Is it that's always the one thing that's confusing me, because it's like it's 2:30 right here, which means it's like 4 a.m. in Australia? Nah, it's the other way around. Still, it's like midnight in Australia. That's crazy. Alright, so we got X, Y, Z, and then extruder as motor 4, and this one just plugs in right here, and that's the wire that goes up the pillar right there and into basically into the gamma pillar over here, right in the center of this V-rail. and then comes out the top. Someone was asking about the motors and why they are so beefy. I looked these up. I actually called them out for what they weren't in the Atom Live build stream, because I hadn't known the exact type number yet. These are relatively low current motors. Actually, these are like 1 amp or 1.2 ish. They are around 1 amp of current. They have a high inductance, which allows them to produce torque with such a low current, which means high inductance. They have a high dynamic voltage, which means as soon as they start turning, they're going to produce large induced voltages, which means you should be using a higher voltage power supply to drive these to their full potential. However, you can use them with these comparatively weak drivers we're using here with the Allegro ones, which work well until like 1.5 amps, and then they start crapping out basically. It is a trade-off as always. I think these are sort of oversized. You could have gotten away with like half the size. These are rated for 62 Newton centimeters. Too much, but they work, and they don't get warm, so I guess that's a pro. Right. Where do we move on? Okay. Motors connected. Got that. So, thermistors, next up. Because we shouldn't forget connecting these, so let's connect them right now. We've got these two friendly crimps without a housing, which are the hot end thermistor. And thermistor on this lovely board, thermistors go right over here. And actually, I did set myself a bookmark for for a wiring diagram, which you guys can follow along, and that's also on the wiki. There you go. So that's what I'm looking at right now, just for reference, and that basically tells you everything that needs to be hooked up. So T1 is going to be where we connect our hot end, and T2 is going to be where we hook up our heated bed. So T1 was, I shouldn't have closed that. So T1 is towards the bed's edge, so right over here. Below these, right there. And this one is already capped and insulated, so I guess it's the lazy man's way of using like crimp-on connectors if they don't fit anywhere else. Okay, that's that. And the problem with this connector over here for the heated bed is it's also got this large plastic housing on there. I think I'm just going to take that off and use the bare crimps right there just to make it a bit easier to plug stuff in. But we're gonna do that once we get into wiring the heaters for this, because yeah, it's a bit short and we'd have it pulling on it the entire time. So next up, fans. Yeah, let's do fans. So these two gentlemen right here are the clamps I put in there just to make it a bit easier to splice them together, because you are physically splicing together two wires from the fans that come from the effector into two wires that are actually connected to the board. And these sort of clamps work much better than what was supplied, so I'm using these. Now, can we still unplug them over here? Yes, no, we can't. Oh, okay. Well, that's a mistake, but we can still screw them in. So question is, we've got two fan outputs. I just get in from over here. We got two fan inputs. We got PWM 0 and PWM 1, I believe. We are just going to declare PWM 1. Let me see if there's an official suggestion. Heat shrink around bear crimps, yeah, that would work as well. If you like really tight on space. If jumpers are set. Okay, so I will need to put a jumper on here to like have them run off the main supply voltage. Otherwise we get a separate input right there, which we're not going to use. These all run off of the same 12 volts. Then, and stops next. All right, fan. There's one fan, there's the other. So, yeah, apparently we should have moved this thing a bit further up, but that's my fault. Now these are the part cooling fans. The other fans that we have are is the hot end fan? Let's see if I can find that one. Got two black wires, that's an end stop I guess, because I did recrimp that one. Now what I can see right there is this wire is going to be too short. That's the hot end heater, and yeah. I'm gonna have to extend that one. Can I use a crimp? No. That's that. Okay, there's the other fan. And that's the hot end fan. We could, yeah, I'm also gonna have to extend this one. Haha. We could just plug this one into 12 volt and have it going the entire time. However, that would not be elegant at all. And you know, we're already trying to get away from non-elegant solutions. So let's extend this one and yeah, and have it actually controlled by the board. Right, 2 wires to extend, I guess. Well, let's get this. Let's get the other one in first. I'll be back in a second. I'll grab some wire to extend these. Oh, we've got a new dryer going out, like going on like a few meters outside of that door, and it smells like dry clothes, but it also smells like burnt clothes, which is kind of unsettling. But I guess it's just the smell of that dryer getting worn in. Arthur, yeah, ruining yourself. So, for the duration of the stream, so I guess that's not going to be useful for the recording, but if you want to get the smoothie board at a discount, or anything else on Robot Seed? Off everything. Okay, 15% off everything on Robot Seed right now, using coupon code TOMSTREAM. You can get your smoothie boards for less than you'd normally pay, which is great, because getting stuff cheaper is always nice. What was I going to do? I was going to extend this wire. Okay. Now orange and green. I'm thinking orange would be positive, but I'm not sure. That's what I'm saying here. This wire stripper is like, it's Knipex. It's like a brand name stuff, but for these small wires, it sort of doesn't work. Ramson Arduino Mega in his DaVinci. I guess it's the DaVinci is like closed source proprietary hardware, right? I guess it's better than that, but RAMs, really? I don't think you should be using rams for anything these days, unless it's like a, you know, throwaway project. But for an actual 3D printer, rams, yeah. It's just one it's a really old design. Two, it's a really bad design. That's the other thing. Just poly fuses, they don't work. They've been proven to not work many times. Not only do they trigger when you don't want them to trigger. I've actually had that happen. I've had the poly fuses cause some very nasty issues where they would get hot and then the bed wouldn't heat up properly, and you know, all sorts of weird stuff. Plus, you know, either that happens or you go the complete other way and they don't trigger properly, which I guess is equally worse, equally bad. But yeah, don't use rams. That's all I want you to take away from that. Don't use rams. Use something decent. At least use like a Rambo or something. It's just so much nicer hardware. I know, it's cheap and it's like, it's tempting. Just go really cheap, but don't use it. Yeah, so Smoothieboard right now. Smoothieboard right now is a 5 motor max platform. The Smoothieboard V2 will have you know, a modular motor system where you can just add on boards and like make it a 25 motor beast. I don't think that's possible with the V1 yet. You can grab external drivers if you wreck your internal ones, or if you want something beefier. Yes, you can just grab the step direction pins from that. But I don't think you can actually add more. There we go. I think I need some heat shrink for that. Ooh, do you guys see the smoke there? Guess I do have a bit much solder on there. The name of my soldering station, it's an AT3D. It's like I wouldn't really recommend it. It's labeled as 80 watts, but it's actually just 60. It only has a 60 watt power supply in there. Plus the irons you have to get if you want a replacement, they are a 10907. So if you look on AliExpress, the 907 is like a super common iron, but only the Hakko 907, not the A10. The A10 907 is a completely different thing. It doesn't have a temperature sensor, it just has 2 wires basically, so it's got a PTC or something in there. And it's like 12 or 13 bucks just for the iron. The Hakko ones you can buy for a lot less. So yeah, it looks like a very regular common design, the DDR10 8080D, but I wouldn't recommend that. Let's see, 1, 2, yeah, whatever, that should fit. I'm hoping I'm not going to blow any fuse with the heat gun here, but there's only one way to find out. Question is, what can I unplug? Oh, we've got one over here. There we go. I'm still looking for like a good solution for doing exactly this, for like extending wires without having to buy like €80 connectors or super special crimping tools and stuff. And you know, if soldering wires together like that is okay if you have like a few like we have now, but if you've got to extend like a Cat 5 cable for, you know, obviously not for Ethernet reasons. If you got like 8 pins to extend or even more, it gets tedious. It gets like really tedious. So I'd like to know, do you guys know anything that works for that just lets you extend little wires like that with less work than what I'm doing here? That would be sweet. Now, power cooling fan right there, okay. And we're going to connect that after we do this one in the corner, because that's going to be tougher to get to. Okay, so this one goes to the second output, and positive is towards me. So let's get this one in here. Let's see if I can get this one in first try. Question is, are these already open or not? Yep. Twist the wires together and duct tape. Yeah, I mean, that might be great for starting a campfire, but I wouldn't want to use that in a productive environment. Of course, I mean, using clamps like this does work for mains and stuff. But ooh, solder sleeve. Yes, those. The solder sleeves. Have you guys used anything like that where you they do seem like a cool concept. However, I think I've been hearing like a few things where they're like they don't work. Basically, what the solder, what are they called? Heat shrink solder connectors, whatever that they have a low melting point solder in there, which you just use like a heat shrink. You have a piece of heat shrink on the outside, and then on the inside you actually have that solder which connects your wires together. So you just insert both ends of your wire, and I don't know, twist them together or something, and then heat shrink it, and it's connected. That's the idea behind it. That sounds like a good concept. Okay, got that one in. Then these, the good thing is these don't have any conductive stuff sticking out, so we don't need to worry about them shorting stuff out. A mod could ban 66 group. Yeah. Ferrules, yeah, they do work for like the larger. I mean, I do have the regular crimp connection set that you use for like mains and stuff, where you have what is it, 0.5 millimeters squared up to like 4 millimeters squared. You just crimp together. That works awesomely, and those connectors are like super cheap. But I don't think you can get a similar thing with like the insulation on there already for these smaller wire sizes. Otterhusen, yeah, that's what Otterhusen, aka Ferrules, that's what comes with came with the E3D hot ends while they were still using the screw-on thermistor, or drop-in glass speed thermistor. Now they're doing the cartridges, and you basically don't need to crimp stuff anymore. Can I have a discount? Well, you guys can get a discount. What was it? Tom's stream, all caps on Robot Seed. You can get the Smoothieboard 15% off during this stream only. So if you buy one right now, you can get it for 15% less than what you'd normally pay. Right. What's up next? Okay, so we got the first thermistors in there. We're not going to be bothering with the heated bed thermistor. We've got the two fans wired up. We've got the hot end fan connected to the second output, the second low power or mid power output. These are still 5 amp outputs, by the way. These big ones take 12 amps, so you could have like a dual heater hot end and a regular heated bed. and then a regular heater hot end does connect to these 5 amp outputs right here. But we do have the 2 fans connected here, the hot end and the part cooling fan. Next up, there's a little fly here. Hello, fly. Next up, the hot end heater itself, which we also have to extend because it's too short. Which I believe are these 2 wires right there. Yeah, get 50% off at Robot Seed, only today. I guess until we see like a 50% off, it's gonna have to be like a huge stock clearance for the Smoothieboard 2 or something. Right now it's 15% off, 1.5, so that's a bit less than 50, but still a good deal. I hate this wire stripper. Hot end heater. That's signal, but the thermistor also yellow, so that's gonna work. Gonna have the hot end heater on the yellow wires and the thermistor on yellow as well, so those 2 match up. I know we should be buying these on spools, but I usually don't use like an entire spool. There. Better connectors than those gray ones. Which gray ones are you talking about? What gauge wire am I using? That's a good point. That is actually a good point. So this is like 0.5 squared, I believe. It should be okay for the hot end heater because this is also a pretty slim wire right there, but I think you've got a good point there. I might look into using something a bit thicker. Maybe not this. This is going to be for the heated bed. This is 1.5 squared. Haven't had lunch yet, by the way. That's gonna be my lunch. Not sponsored by Joyland. So this is like 0.75 squared millimeters, so it should be a bit better. I just have this one piece left, but well, it's gonna be okay for this. So got this much. Do you have a CNC? Arthur actually was like, hey man, you want a CNC? You want to do some guides on CNC and laser stuff? I do have a CNC, which I might be able to show you. I mean, Smoothie is not just a 3D printer platform. Smoothie is also, gosh, that thing is heavy. Smoothie is also a CNC platform. So that is, there we go. Can you see that? Sort of. Let's move over here. So that is that is what my CNC sort of looks like. It's the Mendel Max 3 converted to a Dremel mill. I'm gonna set this thing down now. It's kind of heavy. I did a whole bunch of hardware mods to it to stiffen up, especially the Z-axis. But it's still sort of wobbly and sheet metal based and. It works fine for like engraving acrylic and cutting stuff out of MDF every now and then, but it's not like a great experience as a CNC per se. So wouldn't really recommend that. I also have, oops, that didn't work. I also have a, what is it called? El Cheapo laser. Which I still have not used because it's like if if you look at the hardware I have here of that thing, it's like you wouldn't want to use that either. It looks super sketchy. I am super scared for my eyesight because it's like a 1 or 2. I think I got the 2-watt version. It's a 2-watt laser, and if you get that into your eye, it's like it's over. Your eye is gonna be toast. And I do have some UVEX glasses that supposedly work as laser safety goggles, but I'm still scared. Yeah, that's my lunch. Yeah, didn't have time for actually having a regular lunch, so that's all I get for today. Have you seen the MP-CNC, so the mostly printed CNC project? Yes, I've seen that. I've seen that. It's like, it could work. It could work, to be honest. I have no idea how well it actually does work and how it stacks up against like a 3D printer frame, like I just showed you guys, as a CNC, but it looks like an interesting project actually, and I think I have most of the hardware to build it here already. Do I drink Joyland or Soylent? For occasions like this, that I mean, it's not my normal nutrition. I'm not that deep into it yet, but it's like I don't have time. I need something that's not gonna mess up my entire body for the next 2 weeks, or for the next two days, and actually give me some nutrition. That's what I consume, and it's Joyland because in Europe you cannot get the actual original Soylent. You can only get the Joyland from the Netherlands, which is kind of similar. I guess it's pretty much the same stuff, but yeah. Looks like that really strong alcohol lemon liquor that they have in Europe. Thomas, are you getting drunk? Nope. Europeans don't get drunk as easily as Americans. I mean, look at what sort of beer you guys have. That stuff is a joke. By the way, it's Oktoberfest. Yeah, the Oktoberfest is going strong right now. I think they started yesterday. They have their entire what was it? The Einzug, Umzug, where they have like the entire, all the breweries, carts walking in and doing like their festive march and stuff. That's going on right now in Munich. It's crazy. I've had some friends over there. They were on the highway yesterday, and they were like, yeah, there's a bit of a traffic jam around Munich, as usual. It's crazy. Munich is, by the way, that's the wrong spot. Munich is like an hour away from me. I've never been. Well, I've been to the Oktoberfest, but I've never been like drinking on the Oktoberfest because seriously, what's like one Maß beer, one liter of beer is like $15, $12? I don't know. Ridiculously expensive, and I don't see the point in that. Yeah, I mean, I'm sure you guys have craft beer and that sort of stuff as well. I'm not saying like all American beer is crap, but like the stuff you really label, hey, this is American beer, this is a Bud Light, this is a typical American beer. Yeah, you get the idea. Can I take this one off at least? Yes. Last year it was €10. Yeah, €10 for the Maß, for the one Krug beer, basically Maßkrug beer, plus tips, obviously. So you're not just gonna pay $10 straight. You're gonna add a bit of a tip to that, and it's like, for that sort of money, I can literally buy an entire case of beer, which is a bit more than just 1 liter. So if you only go in there for the atmosphere, for soaking the mass-produced Bavarian atmosphere, then go for it. Not my thing. Right. Let's make sure we actually connect these properly. Where are we? Okay, so I'm looking at the wiring diagram again. So we've got two equal big MOSFETs. Let's use the Q6 for the... So Q6 is this one over here, and then we got Q7 over here. So we're going to use Q6, this one right here, and plug that in and use that for the hot end heater. And the other one for the heated bed. And I think I'm just going to leave it as is. I mean, we could... I would have to extend this. We could use the MOSFET directly on here. We're just going to keep it wired up as is, just because I'm lazy. Yeah, so the motors on Atom are... Well, I'm looking for an option to get you the exact number. You know, before I keep fighting with this, I'm just going to plug in the webcam and give you a close-up, because I have a feeling I'm actually going to be needing this webcam a bit more during today's stream. And I'm hoping none of the cameras are dropping out right now. There we go, there is the webcam. Webcam. Why is that not working? HP webcam. Okay, so even if I try, it's not working. That is great. Wow. Alright, no webcam for you, unfortunately. So the motors are, by the way, you can scroll back to this exact moment to like get a reference for it. The motors are Mineba Co. Limited, made in Thailand. 17PM-KA39BN03CN. So KA39BN03CN. That's the exact type. You can look that up if you want. They're 62 Newton centimeters, 1 amp motors. They are a bit overkill, but they work. They don't get warm. And yeah, they should be okay for this sort of application. And alright, I am actually going to need a bigger screwdriver, obviously. I am going to grab a bigger screwdriver and then wire these into over here. Not use the Smoothieboard's MOSFET on there, just because. Well, hold on. Let me know. Okay, so here's the decision we need to make at this point. One, we take out the SSR, we take out the solid state relay and have the Smoothieboard drive the heated bed directly. Option two is we actually make these longer, connect them to the Smoothieboard, but we still need some sort of power source, which would be these two. That's the easier one. Should we get rid of the SSR, or should we just leave that in there and get on with the project? Let me know. I'm not gonna make get a Nightblood vote in there. That would be too much work. But let me know, what should we do? Get rid of the SSR, or go the easy way and just leave it in there? So that's the end stop right there. X, Y, this one right there. That is the our SSR is not bad with PID. This is a DC-DC SSR, so we should be good. Tweezers, where are thou? Cat needed help. Greetings to your cat, Arthur. SSRs are okay with PID. If you have an AC SSR, it's only going to reset once the voltage actually goes through a 0 point, because the way the AC SSRs work is basically you trigger it, you basically enable it at any point, and then once your AC voltage goes, it's like that. As soon as your AC voltage goes through that 0 point, it resets and shuts off if you're not still triggering it, enabling it. That can cause a bit of an unpredictable behavior with PID, but usually it's not a problem. I used it on my Zabriskie and just like that, and it's working out fine, just fine. Keep it. Okay, keep it. SSR makes it safer? No, it doesn't. It does not make it safer at all, because both the SSR and the internal MOSFET are up to spec. Actually, the difference we would be able to see is that the bed heats up faster with the MOSFET of the Smoothieboard, because this drops much less voltage than the SSR. The SSRs typically drop around like 1 to 2 volts, depending on what sort of an SSR you get, and that can actually make a huge difference on a 12 volt consumer like the heated bed, because I mean it's what is voltage squared through over resistance. That's going to be the power you will be pumping through the heated bed. So if you get, let's just go with 90%. Yeah, so if you only get 90% of the voltage, you will only get 81% of your heating output. And that does make a difference. That is actually noticeable in heat up times and reachable temperatures. So this one is just the Z min end stop that I took out of its connector, and we'll be jamming between the Z max and the Y max. Did I hook up power already? I hooked up the hot end heater right there. There's the power input between those two. So this is what's going to be driving the SSR. Then I guess we're going to leave that in. And the power from the power supply actually comes through these two brown and blue wires, which totally doesn't make sense color-wise, but hey, I'm just going to roll with it. Next up, let's just, while we're at it, while I'm dealing with the end stops here, let's do those and move on. Okay, end stops. So these end stops are not in focus. Oh, they are. So these end stops are actually labeled X-min, X-max, Y-min, Y-max, Z-min, Z-max. So that sort of corresponds to your alpha, beta, gamma motors, or your X, Y, Z motors. That's why I wrote both of the nomenclatures on it there, both of the sorts of ways they are named. So yeah, we can refer to this one as the X pillar or the alpha pillar, and the end stop from this one will go to the maximum input, because it's all the way up top, the maximum length of the X-axis. So now what we need to keep in mind is the way the Atom's end stops are set up is they only use 2 wires. Typically you have like you have 5 volt, you have ground, and then you have signal out, and these only have basically the switch. So these two get shorted out once the end stop is triggered up here. So we don't like have a separate signal output, which means we need to supply a voltage, a low current voltage to one of these, which then gets either transferred to or pulled down to the other, or let's just start over. Okay, so what we'll need to do is we will need to use a pull-up in the microcontroller. So one of these will be the signal pin, the signal and pull-up, so that the board will actually apply a voltage to this one pin that doesn't have a lot of output current. So once the switch closes, it's actually going to pull this voltage down to the ground level, which the other one is going to be. So yeah, that's basically the way we can use a two-wire interface for an end stop. And to make use of that, we need to make sure we plug it in properly, which means we need the actual input for the microcontroller, and we need ground on the other pin. And that does line up. That does line up with the pins on the... Oh, that's so large. There we go. Can I zoom out here? Okay, screen cap. Yay! But why is it going away? There we go. That does line up with the way the smoothie board, that's my key combination. That's the way the smoothie board likes to be hooked up. So we've got ground in the center right there, and we've got the input to the microcontroller right there. So these two pins are what we need. We can completely ignore the 5 volt because, again, we don't need it. Pull-ups are configurable on regular Marlin boards. We can, you know, that's the way the stock board is using it. I just realized that the camera wasn't the way. That's the way the stock board is set up, but Smoothieboard also has the pull-ups. So that's just something we need to keep in mind when configuring the firmware in a second. Yeah, so what we need is this signal right here. These two signals we are going to use. We have a pull up. We're going to enable a pull up, so the board is going to configure 5 volts or apply 5 volts to this. And as soon as the switch closes, it's going to pull this line down to ground, and that's what the mainboard will be able to sense. So that's towards the edge of the board. So towards this side, we've got the 2 pins that we need. So we've got this one over here is the signal pin, and this one in center is the ground pin, and the next one is 5 volt, which we don't need. So this is X max. These are the two pins we have. So this one plugs in like that, and it will sit on. Come on, there we go. And it will actually sit on the ground and the Z maximum, or X maximum in that case. Perfect. Where did my windows go? Too many screens. Too many streams. Tom Stream is discount code 15% off. 15, that is 15. 15% off the smoothie board on Robot Seat right now. That's actually a pretty good deal. Right, X-Max end stop. Next up, Y-Max end stop. This one already has the connector shredded from the build stream, which is completely my fault. Min, X-Max, Y-Min, Y-Max. Okay, I think I just scratched my glasses. That's okay. Oh, no. They're already scratched, so no problem there. So that's Y-Max there, and then we've got the... Where are you? Now this one I actually had to crimp new DuPont connectors onto because I completely shredded them. And where is the other one? Where's the other one? Are you hiding? There you are. Okay. These two are the Z-axis maximum. Now this is we'll have to see how we can get these out of the way a bit more, because right now it's just a mess. Z-Max right there. And then the two gray wires, which are the clicky, crap, I keep forgetting these are magnetic, which is the, you can probably hear that, that's the clicky switch in the end stop that actually triggers the bed sensing. That one goes to the minimum because that's what it is. It is the minimum position for the Z-axis. And we've got heat shrink on there, which makes it a bit harder to push in, but still makes good contact. I guess. There we go. Ooh, I should bend it. Nobody saw that, right? Okay. Let's clean out the heat bed. Yeah, can't recommend an auto height sensor enough. Same for me. You know, auto bed leveling, as it's commonly called. It's not leveling because you're not actually aligning it to gravity. It's like auto bed squaring, more or less, because you are aligning it to the rest of the printer's axis. That has been one of the huge features of 2015. It just makes using your 3D printer so much easier. It's like a cheat code, basically. You don't have to ever worry about aligning your bed to the rest of your printer again. You don't have to worry about leveling that again. And it's just, you can start a print without worrying about stuff. So that's, you're gonna see it in the Prusa review tomorrow. I call it a must-have feature, and I would totally agree with that. Right here again, it's like, you know, you should have that in any 3D printer if you want to buy one today, unless you're buying like super cheap Chinese kits, which you know my opinion on that. Those often don't come with auto bed leveling sensors, but you get what you pay for, right? So I realized I need a new or a different screwdriver to actually remove the cables here. I'm not going to tie on to these two wires that go to the SSR. I'm quickly going to grab a new screwdriver that actually fits there. Whew. Yeah, so a while ago someone was asking about, oh wow, what sort of idiot screwed these in so tightly? A while ago someone was asking about linear rails versus like, you know, the MGN type high wind rails or THK rails that are used in this machine as well. If you zoom out a bit, you can see them. You cannot see them. That is, wow. Maybe now you can see them. You can't. Wow. So this machine uses THK linear rails. You can just see the bottom of one right here. Which is your custom or your properly purpose-made linear rail system for this sort of an application. However, the LM8U is still very, very popular. It still sort of works out. I mean, if you use it right, that there are a lot of bad designs. There are also a lot of good designs that use LM8U. And like Egos rails and other supported rail solutions and stuff. What are you guys using? I'm guessing it's M8U or M12U or a bigger, smaller version of that. But do you have any experiences with LM whatever versus other solutions? Because I did make my experiences with them with either one. And right now, like, well, whatever works. If you're using it properly, then you can get like good prints. I mean, we are still talking about 3D printing here. You can get pretty awesome 3D prints with either solution. Let's see. Okay, so these SSRs do have a polarity on the input, and the DC to DC SSRs also have a polarity on the output. Output should already be wired up properly. The input, we need to take care that we're not reversing it in any way. I guess that would be bad, or, well, it's just, I mean, it's just an LED. That would at least not work. Yeah, deltas are still voodoo magic. Ha! I mean, I'm pretty happy that I didn't have to calibrate a fully calibrated delta yet. I think I pointed it out in some sort of stream already, but the Zabriskie, which was like my custom designed delta, that one was all basically calibrated by the Smoothieboard, and that one was working pretty perfectly. This one right here, the Atom, of course, came pre-calibrated, pre-configured, so I didn't have to calibrate anything there either, which I'm also very happy about. And I don't really want to ever have to completely do that from scratch. Right. So we've got positive again towards the right side as it looks. Yeah, so I've been thinking about using linear rails for my Mendel 90, because that one is officially put out of service. And I was thinking about like redesigning the x-axis so it's like a single sheet of plywood that's like across from all the way over here to the opposite side over here. That just has like linear rails mounted onto it. I think that would be pretty sweet, but I don't know how much of an advantage we're actually going to be having there. So because we are, how far into the stream are we? Let's just check. Because we are 2.5 hours in the stream, into the stream, so I guess we should take another stab at what we're doing and why we're doing it and such. I mean, you can scroll back to the beginning of the stream if you want that, but let's just recap what we've done, what we're doing, and how we are going on with it. Actually, before that, I'm just gonna get some crimps to fix that up. So, what happened so far? We grabbed the original Atom3D 2.0 control board. I hear rain. And ripped it out of the Atom 2.0. Then we put in a Smoothieboard, at least hardware-wise. So that's in there already. We adapted the mounting points. We wired all the motors up and stuff. Last thing to do now is connect the power to the power input, which is, I can never remember. I'll have to look it up. Which we'll have to connect to the power inputs, and then I think we can close this thing off and actually get to using it and calibrating or setting up the firmware. Okay, thermistor, that's the one more thing. Bed thermistor, that's one thing we still have to connect. But basically, what we are trying to achieve here is, let's get back here, there we go. What we're trying to achieve here is a better performance of this Delta machine, because as I've pointed out in the review of the Atom 2.0, a 8-bit controller is sort of underpowered for a Delta 3D printer. It does work, it does print, but it slows down a lot when you try to, for example, use the LCD. While we're at it, if you try to push it harder than what it can handle right out of the box, then the 8-bit processor in the Arduino-based systems will start to struggle. And that's why we have a Smoothieboard in here, which has a 32-bit 120 megahertz. Why are you not working? 120 megahertz processor to make those delta calculations faster. Let's close that window. To make the delta calculations faster, to take a bit of a... My camera is dead. This one is still working. Yeah, to make the delta calculations faster, to do less interpolation between the individual points that the processor can actually calculate, and basically to just give us a better experience. And as a bonus, we are also getting shit. There we go. As a bonus, we're also getting network functionality with this board. So we are basically getting where's our focus? Right about there. We're also getting an Ethernet port that we will connect to the local network here, but this is something you can use directly on a computer with a regular web browser, or in our case, if we got the time for it, we are also going to add an Android tablet to this machine. Just put it right there on the original LCD screen, and put that on there and use that as a web-based interface, basically. So that's our motivation right there. And so far, we've managed to wire in the hardware. Just one more thing, we need to add the power input to the board, and then is that large enough? Maybe. And then we can get into. Ooh, that fits perfectly. Get into configuring firmware. No? What? No. What? Yes? No? Chat, what's going on? Am I missing something? There's one. Fro smoothie? Oh, that one. That one's crap. An app, it's not actually an app, it's also a web-based interface. You can actually try out Fabrica. If you Google it, you will eventually find a link. Arthur might actually post it, but it's not much use without a smoothie board on the same network. So if you have a smoothie board already, you can try that out. If not, it's just going to be a finding your next smoothie board, which is not going to turn up anything. So yeah, we've got the basic web interface, and we've also got the basic web interface that the smoothie board itself provides, and then the improved, shinier version with Fabrica, basically. Oh, Android app, that's cool. So basically, Android app, that's going to be sweet. I mean, I realize a lot of Android apps these days are more or less just web interfaces in a nice shell. Basically, just having an app that gets you to click on it more often. But to be fair, I mean, bookmark versus a native experience, I'd still prefer like the native one, because you know you don't have all that browser decor around it, and you just get a more streamlined and faster experience. Also, I mean, if you're adding like useful features to it, then go all for it, obviously. It's coffee time. It might actually be. However, I don't think... You know, I'd have to desert you guys for a few minutes. I actually bought a Bialetti Bricca yesterday, which is an espresso maker, not like one of those maca makers that you put on your stove, but an actual espresso maker that brews with some pressure. And that espresso is like that stuff is awesome. But it takes a while, and I don't really like want to leave you guys hanging for that long. But I would like an espresso right now. It's like a 2-cup maker, so I mean, who drinks a single espresso? You know, Dobbio for the win, right? So yeah, that's something I'm not gonna be having today, unfortunately. There's that. So positive is the marked one. And I think this is, you know what, actually before I crimp this thing in, before I crimp this thing onto the actual power supply and input wire, I am going to measure it, because the one thing I don't want to do right now is to actually feed the smoothie board power in reverse and blow everything up first try. That would sort of suck. Hold on, is this one an output? Is this one or an input? Let me just check. And of course I am going to check again that I'm not miswiring anything and like hooking output power or input power to an output. Ooh, what? Power in 1. Maybe in if jump is a set key and switch VBB, else switch the. Just show you guys that. Let's get that camera out of the way. So we've got the outputs here, power in 1, and we've also got the other power in here. We've got VBB in, and we've got ground, which is over here, 12 to 24 volts. And then we've got another power in right between the MOSFETs right here. So that's where our SSR is connected. That's where the heater MOSFET is connected. And then between those two, we do have VBB and ground. So we could connect power either... Nope. hold on, buttons, there we go, haha. We could connect power either here or over here, totally wouldn't matter. I kind of do want to wire it up here because, you know, I already set it up to with this connector. I mean, it also fits here. Does it? The other way around. It also fits here, but this one just doesn't pop out that far. And because we are going to have that heated bed on there, I'm just going to keep it low profile and keep it right over here. If I can actually get it to plug in. There we go. Ah, sweet. Tom, no? No? What? No? What? I need power on the main pin input? Are those not? Is that one not bridged to the other one? Danger, danger. I see you, chat. I see you. You need both. There are MOSFETs to bridge the inputs, but they are 4 amps max. Ooh, okay. That just saved us a bit of a headache. Okay, I need both. Okay, so I need to hook one up here and right there. And we've got one more connector. I think we should have like a second one somewhere. Jumpers, you need jumpers to bridge. So that's like solder jumpers. I believe that is that these in here? Let's just check that out again. We should have it on the... That's to switch power in 1 voltage. So I need both. Arthur, can I just let's switch over here? Can I just solder these shut over here and then just connect one? That would be a nice alternative because I mean, the thing is that they are labeled the same. They are labeled ground in VBB, and if we head over here to the main input, over here, they're also labeled in, okay, VBB in and ground. So the question is, can I just solder these shut, put a big blob on there, and close those off like that? Does that work? Those tracks are limited to 4 amps. Okay, so both. Okay, which means I do have to take these crimps off again because, well, 4 amps. I mean, we are not going to do more than 4 amps on the output here. We have the motors, which are a bit. Then we've got the heater, which isn't a full 4 amp heater. So we should be fine, but just to be safe. Let's take these off, put a bigger crimp on them, and grab another set of wires to wire to the main input. If you have a bed, you need both inputs. Yes, the bed is still being controlled by the SSR, so there is no current flowing through the Smoothieboard for the heated bed, other than what's now being output to the SSR itself, which is like a handful of milliamps. So okay, 1, 2, there we go. And let's just get this one into the other clamp as well. VBB. So that's right. I think that was me. You know, it says Thomas Sandra hat Krish Sava book here. Anyways, credit where credit is due. Anyways, power inputs, where are we? We are over here, VB in, so positive goes towards me in this one, so right over here, that's like the main input. We do not need the 5 volt in because we have the regulator. Would be interesting if we need another bridge or something. but we do need that VBB in that main 12 to 24 volt, which has the positive one facing towards me. So let's do that again. There we go. So positive is this one. Positive is this one. And chat, remind me to double check these before we plug everything in and before we actually power it up, because having these, you know, with the wrong polarity, that would probably melt a few things, unfortunately. Right. Okay. There we go, so that should be okay. This goes in here, so positive goes this way. Also, good idea to do is just always have your grounds marked. You know, typically, you know, capacitors have their negative line marked. Diodes have what points to the negative side when they're conductive marked. So I'm just going to do exactly that and just mark the negative inputs, because these are sort of confusing over here. You do need to look at the original drawing to make sure you're not reversing the polarity on those. And I am actually going to double check right there as well. Yes, so this one is negative right here, this one is negative here, and this one is negative here. Just to make my timing a bit easier, I think I marked it exactly the same way on my other smoothie board as well. It's just a thing to take a bit of load off my shoulders. All right. We are going to unplug this before we turn it on, but for now, let's crimp all these together. So I am actually going to grab a crimp and run them off of these wires and just split them out to this one and this one over here and shove them both in the same crimp. Or I could use a spring clamp, which I think I should do. Because the crimp I will have to cut off again once I convert this back to stock when testing the Atom 2.5. So yeah, let's do that. As people were asking about Vago-Klemmen before, you know, Vago-Klemmen, which is like the German standard type brand of connectors, and they're typically these translucent bodies where you just shove your solid core wires in the ends and then it grabs onto them. Those work pretty well. However, they only work for thicker solid core wires. I mean, you could shove in like a thinner wire like that, and you know it would kind of hold, but it takes a lot of force to push these in. You know, and it is sort of easy to pull them out if you're only using a thinner one. So these work best for like thicker connections. Then I've got these, which are typically used for lamps. These lamp style connectors in here for the heated for the part cooling fans, and they're like spring loaded clamps that have, I don't know if you can see that. And I have like a little shearing sword connector in here and a test pin on the back. These work like for connecting just two wires together. That is perfect. But again, well, mostly for solid wires, but you can use them for stranded wire like this as well. And then we've got these, which are Chinese ripoffs of the original Vago type spring-loaded clamps, which have, can you, I should zoom you guys a bit further in. Here we go, and that should focus, sort of there. I'm gonna get rid of the bouncing in a second. So if you open these levers, you can actually see the little hole in there opening up and closing up. So these are spring-loaded, and they do sort of work for, as always, that they work best for thicker wires. The original connectors in here were these exact types, but they are not so good for the small wires because they tend to fall out and fail. So because we have the thicker wires here, we are totally fine with that. So it actually tells you to strip insulation for 10 millimeters. So we're going to set the stripper to 10. There we go, that's 10. And strip away. Glump! There we go. Same over here. Yeah, so spam on the chat. Well, it's YouTube. What are you expecting? Also, it's the internet. What are you expecting? There is always going to be a certain amount of spam going on, whether it's YouTube chat, whether it's YouTube comments, whether it's Google Plus communities, who I think Arthur is a mod of as well. It's just the internet. There are some things we can do to deal with them. One of them is Nightbot. One of them is having mods that actually look at what's being written and, you know, get used to it. I used to give much more of a, I used to care a lot more about spam and content that I didn't want to see and didn't think was good to be posted at certain places, but yeah. In the end, it's just a part of what the internet is, and we're not going to be able to get rid of it. We're not going to be able to get rid of a lot of things we don't like, but I guess the best we can do is deal with it, and you know, if you have the tools, ban them, because why not? 1, 2, 3. Yeah, trolls are still there, but at least they can talk. That's, I guess, enough of a punishment for them. Yeah, so these clamps are rated for 16 amps or 25, depending on which number you believe. Oh, 24 or 32. Haha, yeah, right. I mean, obviously, I wouldn't recommend using these Chinese clone clamps for anything that is like safety critical for like actual mains wiring, or for stuff you're not going to have an eye on, like a 3D printer that's going to be printing overnight without any sort of supervision. Can't really recommend the Chinese ones, but I can recommend the genuine Vago clamps. Yep, it's only fun to bully those who react. Right. Right, okay. Got power. This one we are going to take out of its housing in a second. But for now, I'm going to grab a multimeter and we're going to measure the... Can I get a preview player? No. There you go. And we can measure we can measure the voltages that work out here, and we can measure whether they are in the correct polarity, because this power supply is not switched, it's turning on directly if we turn on the power switch. So yeah, the printer is Taiwanese, the printer is from Taiwan. However, the clamps that I'm using here, you know, the entire bag here, that's still in the original German Vago thing. These clamps right here, as well as these look exactly like the original German Bava clamps. However, they are rip-offs. They cost like half, and of course I cannot recommend them because I don't want to, you know, be responsible for anything going wrong with them. But that's what I have here. All right, I'm gonna grab a multimeter and be back in a second. Right, okay. Also, we missed a donation from Dunai1 about half an hour ago. I think it should have shown up on stream. But he's saying just a little appreciation for your infotainment. That is very generous of you. Thank you for that donation. As always, you can send me your tips through StreamTip, which is linked in the video description, and Nightbot is also mentioning it every now and then. Yeah, so if you appreciate the spam control here, awesome, it's working out. Right, so I've got the two power inputs disconnected from the board. These actually have the same polarity, so we could swap them if you wanted to. But let's first plug this printer in and see what it does. So theoretically, what should happen is, let's turn this one off. What should happen is the power supply turns on, nothing else turns on, no smoke whatsoever anywhere else. Let's try that. Perfect. And we should have 12 volts with the negative terminal over here and the positive over here. So let's check that. And these screws here are actually connected, and that is 12 volts perfectly. And let's check this one as well. So that's negative over here. So there and there. And that's also 12. Awesome. So we can connect that. No magic smoke because nothing is connected. So there's still 12 volts on here. So when I plug it in, it should receive its input power. There. And it's going to turn it off in a second. There we go. All right. Got it. If it blows, how fast do you reckon a GIF will make it up on Reddit or Imgur? I don't know about you guys. You might be pretty fast. Also, thanks for the tip from Spike Kent. Great stream as always, Tom. Appreciate that. Right. Next up, Anonymous. €8.96. Is that like a dollar conversion thing? I have no idea. It might be like a weird currency type of thing. No message, but always appreciated. Awesome. Right. It is working. It is. Let's just light this thing up again. See those LEDs? I believe that is how it's supposed to be looking. Click. We just heard the motors engage, and that is exactly what we want to see. Yeah, so the motors were just engaging for a quick second and then instantly turned off again, and that is exactly how a fully functioning smoothie board is supposed to look like. Sweet! Next up, USB. So as you can see, I mean, the LCD is completely disabled at this point because, you know, it's not plugged in or anything. Because we don't need it. We don't need the LCD. We're like strong, independent controller boards that don't need no LCD. Right. next up, firmware configuration. This is going to be a sort of more tedious task, I guess. I mean, we are going to do this on screen cap. I'm going to pull up the original firmware on one side and then the settings from Smoothie on the other. And basically, we are going to do this stepwise. We are going to do one step after the other and then add features onto it one by one. So Arthur and I have sketched this out. So basically, we are going to start off with an example delta configuration. We are going to set up the end stops, check the end stops. We're going to check the heaters. We're going to add a hot end fan trigger so that the hot end actually turns on at a specific temperature and keeps the upper part of the hot end from overheating. Then we are going to check all the moves, check that everything is moving as it should. We are also going to add the Z probe. I like clicking that thing. Hi, you can actually hear that click. Sweet. We're going to set up the Z probe, then we're going to do an auto delta calibration run. We're going to tell it the stock settings that the firmware on the original board came with, and then we're going to let Smoothie calibrate itself in. And then we're going to add delta grid leveling, which is basically delta or mesh leveling as on the Prusa i3 Mark II, but for a delta concept where it probes a whole bunch of points and then compensate for bed tilt between those. So that's what we are going to do. How are you going to do the temperature fan? The M109 is blocking it from turning on while heating up. I was considering to add a sub fan command to it. The way I've got it set up on the Zabriskie board is, can I get the SD card out of that? Have it set up as an output and then basically add that temperature trigger block to turn it on when necessary. All of this out of the way first, and that is actually working pretty well. And I'm at least not on the Smoothie board. I didn't have any issues of it being blocked while heating up. I believe IRC as always. Right. Let's get rid of that. Put that over here. This one is still good. So the Smoothie board does come with all the connectors you need and crimp connectors. I didn't use any of those. I used the original green ones, but not the crimps. So if you just have a printer that has bare wires, you can crimp all of that up if you wanted to. If you have the crimping tool for that. I did not do that. I hate crimping. I know how to crimp. I can get good crimps, but I just don't enjoy doing it. Just one of those things where I'd rather not. Right. Let me see. Does that look smooth to you? It looks sort of jittery to me. I think someone pointed out in the beginning of the stream. What sort of sexy 3D printer do I have here? Oh, that doesn't sound good. There you go, the Atom 2.0. Watch the review on YouTube, the latest video I uploaded actually, I believe. Right, firmware. So, Smoothie board comes with an SD card. Right there. There is the SD card in the Smoothie board itself. That is plugged in. Now we can either stay there. We can either grab the SD card out of the board and put it in the laptop and read that, or we could plug in the USB to the computer and then have it access it through that. So the where are we? So the Smoothie board actually exposes two different interfaces on its USB ports. It exposes a serial port, which you can use to control your 3D printer, and it also exposes a mass storage device. Look at that. That's the. I think that is the original cable from the Prusa i3 Mark II. That is That is a long USB cable. I enjoy having long USB cables. Anyways, as I was saying, the Smoothieboard also exposes a mass storage device that lets you write files to the SD card, such as configuration files, etc. And of course, it also lets you modify the configuration. So you get to write the configuration without having to reflash the board, as you'd have to with Marlin-based solutions. Actually, the Smoothie firmware is a constant thing. It's one firmware build that only reads its configuration, so you don't need to reprogram the entire firmware, reflash the entire firmware if you want to make a single change. Right. Good. Let's head over to. I've got too many windows open. This is getting confusing. There's a problem with this drive. Let's click this button. There we go. Select to choose what happens with removable drives. Open folder to view files. Over here. So there's the stock firmware there's the stock SD card contents from the Smoothieboard itself. Too many windows open. Stock firmware from the Smoothieboard itself. So we've got the firmware.cur current. That's the current firmware that's running on the Smoothieboard. But it also comes with a whole lot of other stuff. It comes with a backup firmware, which is stuff that is like a fallback, I guess. Documentation. So it comes with let's have a look at what's in here. So this is basically a mirroring of okay, it's still in the zip container, so that's not going to open up. A mirroring of the entire Smoothie wiki, I believe. And then we've got drivers. If you need drivers for your computer, mine showed it as auto configured and stuff. So if you need a x64, x86 driver, so 42 or 32-bit driver for Windows, you've got that, and OS X and Linux. I guess that is like a, what are you? No drivers are required to use Smoothie on OS X and Linux, so that's cool. What else? Software, so you are getting a whole bunch of stuff along, just bundled. I guess you can download all of this stuff for free from the internet as well. But a whole bunch of CNC tools, Cura Slicer, LaserWeb, which is an Octoprint based laser interface. You're getting Pronterface, you get Slick 3R, you get VisiCut. Just mostly, stuff that you might not know about when it comes to CNC or laser related stuff, but that's still going to come in handy. And of course, source files for the Smoothieboard and for Smoothieware, so for the actual hardware that we have here, as well as the what was I going to say, for the actual Smoothieboard, as well as the firmware that is running on the Smoothie board itself. Right. But now, so config, that is our main config file, which we're completely not going to use. We're not gonna touch that at all. So there, let's take that one. We are actually going to grab the sample. Well, first off, we're going to update the firmware, just to walk you guys through that process, because it is rather easy, I guess. Yeah, so you can grab the configuration file examples, which we definitely want to do in a second. Let's update firmware version. So Smoothie Arthur, if you're listening, do we need to update the firmware on the board itself? I guess we should. Just to make sure we're on the very latest one. before we get into configuring this entire thing. Because that there is a lot of stuff you can configure with Smoothieware. You get a lot of options that you can make work together or make work against each other if you're not careful. It is a different mindset of configuring it versus Marlin, where Marlin you have like your prefixed slots of, okay, you can do this with these parameters and then you can do this with these parameters. In Smoothieware it's a lot more modular in the end. So you can have like what I just mentioned, those temperature switches for the hot end fan. You can have a whole bunch of these switches for LEDs, for different temperatures, for different sort of mechanisms. You can combine them with others. It gives you a whole lot of options. Ugh, I did need that coffee, guys. So let's check that out. So flashing smoothie firmware. Smoothie boards come pre-flashed. So yeah, you do not need to flash your smoothie board when you get it. So it is already functioning as we're seeing. It's already blinking and stuff. But we are still going to reflash it to update it to a more recent version. Step by step. Download. Smoothie Edge or smoothie.html. We're going to just go with this one. The latest binary is also available here. Let's grab this one. Trapeze rods or threaded rods, which is better? Trapeze rods because they're made for the job. Threaded rods. Ooh, Smoothieware, what's wrong with you? Trapeze rods are made for the job, and threaded rods will have a lot higher losses. Which one did I just try? Threaded rods will have a lot higher losses when it comes to just linear motion. As soon as you apply any sort of pressure to it, you are going to instantly feel that in the torque required to turn it. So yeah, trapeze rods, if you got the option, go with that, definitely. So let's save that, and let's actually save that to the smoothie right there, firmware.bin. You are late to the party, Farbauti. Farbauti. You can actually scroll back or wind back, reverse, whatever it's called, 4 hours into the stream on YouTube, which I think is kind of a cool feature. There you go. So yeah, raw or download. All right, so copy the firmware bin to a micro SD card and safely remove the SD card from your computer. Let's do that. Make sure the file is named firmware.bin and nothing else. And that is exactly what it's called. So let's eject this one. Save to remove hardware, and we do now need to plug the SD card in the Smoothieboard SD card slot. Yeah, so we did that already. I guess we just need to power cycle it for now, and that's off. Let's wait until that stops blinking, and then you can see what we just heard the USB disconnect sound over there. Just wait until that is completely off, and then we can what? Oh, let's unplug that too, because it's gonna get power from USB. Okay, turn that on, and let's see what it does. You can only rewind 2 hours back? That's false advertising from YouTube. They told me I could rewind 4 hours. But why? You should see the LEDs count up for a second and then start flashing. Okay, it's not doing that right now. Let's try the power cycle again. I feel like having the USB plugged in might have been a problem there a second ago. Let's just try another power cycle. If not, we're gonna look at the SD card again. 159. Wow. Okay, so it's not doing what it's supposed to do. So officially what it's supposed to do right now is Smoothie will boot and you should see the LEDs count up for a few seconds and they will start flashing. At that point, Smoothie has flashed the latest firmware of Smoothie and is running. That's not doing it right now. I did eject the SD card, however, when powering it down, it did still get power through USB and sort of was probably in like a limbo sort state. So what I'm going to do now is grab that SD card and physically plug it into my computer and see what the files look on there. So power is off. Let's grab that micro SD card right there. And plug that thing in all the way around. Right, yeah, so 30-bit is set. I did eject it properly. So on the Smoothie, we've got firmware.cur. Okay, so I guess the flashing process kind of got cancelled. Let's just download that again. Download, save to Smoothie, firmware.bin. It's downloaded. And let's eject this. Can now be safely removed from the computer. And plug that thing right in here. Yeah, guys, I think it was really just the fact that we still have USB power plugged in, and I saw it kind of like flashing up halfway and not really doing its thing. Let's try it again. Nope. Nope, nope, nope. We broke it. We broke it. The only problem is we're not seeing it flashing. That's the one thing I'm concerned about. Yeah, I will try that and erase firmware.cur. Let's see if it shows up through USB. I guess we can't erase the current firmware through USB. That I mean, it's SD card's dirty anyways. Let's just pull that thing out. And this is usually the point where the hardware manufacturer starts hating me. You know, it's like format the SD card. Okay, I'll try that. I guess Joe Prusha can kind of sing a song about that. Things go wrong when you're doing them live. It's just a matter of fact. So yeah, all this stuff I don't think we need. We're gonna grab a new firmware config anyways. So let's just format that thing from it with FAT32. Yeah, Smoothie, whatever, quick format, go, yes. Format complete, okay, close. Let's just download that again. Save, go, save, done. So right now the firmware.bin is on there, and do we need a firmware configuration? I don't know. I'm actually going to grab the Delta example configuration as well. That's the config for Cartesian machine, and you can actually grab, copy link address. You can actually grab the oh, did I seriously just default config for 3D printing in the GitHub repository? Yes, I am looking for the Delta address. Delta. So Smoothieware, the Smoothieware wiki has an entire page for Delta configuration, which it takes you through the entire process basically. and we are going to grab the example file from GitHub right there. So it's sort of like the same thing as with Marlin, where you have different configuration files for deltas, for Cartesian machine, for Morgan type machines, and you don't want to set up everything manually. Just grab the config. You grab the config and drop that in there to get as much of a drag and drop, click and what's it called? Drop in experience, plug and play. That's the word. Experience as possible. So Smoothie eject. It is now safe to remove the Smoothieboard hardware. Let's grab that and see what it does now. By the way, is that image right here, is that too overexposed for you guys to see? Or, I mean, it is looking quite washed out on my screen. Let's turn it on. The suspense is real. Interesting, still the same. I can feel the frame is still not grounded. Now it is. Where do we have grounding path here? Yeah, so what it's doing right now, if I get this camera out of your way, if we plug it into USB, we're getting a USB device not recognized. Wow. Some would call that talent. Some would call it talent. I am actually going to follow Arthur's suggestions here. Remove VBB and try that again. So this one is all, it's physically unplugged, so no power supply on there. Let's just try USB power, and we're getting one LED. Just getting the one red LED right now. This is normal? What? USB device not recognized? I'm getting USB device not recognized again. If nothing broke midstream, yeah, then it wouldn't be a proper stream. This is normal. I have to put it. Yeah, I have actually observed that with the Zabriskie Reborn hardware as well. The only problem is I don't have a different USB port. I'm all out of USB ports. That's the only problem. I literally have every single USB port that is on this computer, on the USB hub, on this Dell screen that has a 5-port USB hub on there. I've got every single USB port filled up. Let me see what I can unplug. I think I mean if I unplug the what's the word? The mouse or something. That's something I can get rid of. Let's see. So we've got the Smoothieboard plugged in back here. That's unplugged. Let's route that over here. I mean, it wouldn't be live if it wasn't like live, actually. Grab an SD card from somewhere else, format drop firmware and config and try again. Okay. First off, I am going to try a different USB port, which I have like somewhere over here. Yeah. Alright, this is neither elegant nor. Oh, shit. There we go. So that's plugged in into a USB hub, and we're getting USB device not recognized right Where's my mouse? Ah, I don't have a mouse. Right. USB device not recognized. Okay. Which means switching USB port doesn't work. So those are both. Where's my buttons? There's my buttons. So the one was it was just plugged into the monitor. The other one is one is hooked up to the monitor. The monitor is going to one USB port on the laptop. The other one is that I just tried is into a USB hub over here, which is plugged into the other physical port on the laptop. So we should have switched as many USB ports as possible. Next up, trying a different SD card. So we are going to try a, just your regular, where is it? The camera cannot focus on it. Whatever. Kingston 32-bit micro SD HC U3 class 1, whatever it's called. That's what we're gonna try next. I just need to make sure that I'm not having like any footage from the Prusa review or anything on there that I am going to delete as I format everything. Just give me a second there. 32 gigabyte. So that's like, I don't know, 32-bit. That's like a. You could call the Smoothieboard a 4-byte processor. I think this one should be all empty and stuff. System volume information, blah blah blah. I don't need that. Okay, so let's wait. I refresh this. Use that the format. FAT32, 32 kilobytes, Lumix. Yeah. I guess FAT32 should be fine. Yeah. Slower than class 4, yeah. Right. Close. Okay, and let's just grab fresh firmware again. Let's grab the let's grab the Delta config again. Here. Why do they never sell them as GB bytes? I have no idea. Well, I guess it's cheaper to save or to sell a what? Oh, what? 1 second. I thought we formatted this with Lumix. What the heck? I guess it's what? Why is this showing up as Smoothie? I didn't call it Smoothie. I'm hoping I don't have to reboot my PC. Anyways, firmware. Smoothieboard firmware. There we go. Firmware.bin. I believe that is like the one we want. Download to save that. Save it to Smoothie F. So we've got firmware.bin, we've got config, and that should be it. Check that thing. Windows is trying to ruin the stream. The problem is that I don't actually have. Well, I could try it on my workstation, but I don't know if that would make any difference because that's also a Windows 10 system. Let's grab this one over here. Wow, such focus. There we go. Let's grab that puny 4 gigabyte class 4 card out of there and drop in the massive 32. It might have just been running out of space. No, come on. So the question is, can there be anything hooked up to the Smoothieboard at its regular output ports that would mess with a firmware update, like the end stops, or well, not the motors, or power outputs? Not, but I guess only the end stops. But I don't think that would be its issue. So I'm not going to use USB. I'm actually going to have it power up through the mains power input. Okay, the mains power input, giving it 12 volts, because 12 volt did seem more stable than what we saw through USB with just one LED lighting up. Let's drop it in there. Yeah, use Linux. You just made that comment. You don't have to wait for it. You just made it. It's there now. What? No. Are we missing a jumper? Are we missing a jumper? That's the question. Because we did have. Yeah, when we did we miss a jumper? Because right now it's showing up as VBB, so it's 12 volt but not 3.3. So if I give it USB power plus if I give it USB power plus the 12 volt in, let's see if that does anything and lets it flash itself, because it does appear to still be working as it should, because I mean it is looking at its firmware and renaming it to firmware.cur, so I guess it's flashing it, it's just not showing it, or at least it's seeing something, it's doing something. Let's give it some 5 volts right there. Let's see what that does. Nada. Is 3.3 on or off? It's off right now. And with USB plugged in, there is a faint glow on the 3.3 volt LED. And once I unplug that, the 3.3 volt LED turns off. There's the LEDs we've got there. Let's see if I can actually get the exposure down a bit. There we go. So that's what it's doing right now. So unplug USB, unplug 12 volt. USB is unplugged. I'm going to try and reset it with only 12 volts plugged in. Going to let that go out completely. So now I'm turning on the VBB supply again, and it's just showing VBB glowing and nothing else. Unplug VBB, try with just USB. Okay. The question really is, are we missing some sort of a jumper or something? I mean, it was working at the beginning, but it also had USB plus VBB, so plus mains voltage plugged in. Let's just get rid of the mains input. So I actually unplugged the complete mains input right there, and just with USB and USB not. So that's just USB right now. That is just USB, and that's connected to my monitor with a USB switch, USB hub. And the power on off doesn't do anything because there's nothing plugged in there. I'll try to directly connect it to the board just to get this adapter out of the way as a culprit. And there we go, that's doing nothing as well. Oh my god, 3.3 volt regulator is dead. Maybe. So let's see, we should have a few test points on here. Over here we've got a 3.3 volt, which is something we can probe right now. It shouldn't be flashing the bootloader on firmware update because the bootloader should be what's doing the firmware update itself. So let's grab ground. So we've got USB connected, and it should be getting USB 5 volt from somewhere. Let's just see what it does. So we should have 5 volt right there. There's 4.6. That's good enough. That's interesting. What? Guys. Well, okay, so this one is sort of not supposed to be. Hold on, that's not supposed to in there. What? So, so what I just did, I think, yeah, I did show it out the end stop on the backside. I did show it out 5 volt to ground, which did reset something. I don't know. The other plug was maybe touching the bottom of the end stops there as well. That's definitely not what was supposed to happen there. That's not what what I tried to fix it. Arthur, I have no idea what it was. The USB plug was plugged in properly here. Even with the now it's gone. Now it's back. Oh, what? Wait a second. So if I... Ooh, what? No, that looks good. That looks good. Ah, I see what it is. There we go. So, I guess I mean, yeah. So this is completely my fault. I just saw what it is. You guys see what it is too. I mean, it's sort of a tiny detail. I should have listened to Arthur. I know. Read the instructions. I get it. It's the meta now. But this little uninsulated, my hand's in front of it. This little uninsulated end stop connector right here. That one was tilted over like that a bit more. You hear that? And shorted out to the other pin. That is yeah, I guess yeah. That's my fault. The suspense is real. The suspense is real, guys. Arthur, when I see you in person, I'm gonna buy you a beer. You deserve that. maybe I should like get you a doctor's appointment for like getting you a heart checked out and stuff as well. Again, I do take full responsibility for that. Happens. Right. So let's get this one shrink wrapped. Yeah, you see what it's like a ritual. I mean, we've had let's recap through the past live streams. So what do we have? We had we had the Atom3D light build. We had Mike from Atom3D going completely crazy over chat. We had the Mark II live stream, which most of you probably can remember pretty darn well, which was kind of a shocker to Joe Prusha. We've had the Element live stream, which I've gotten sort of a... I did receive feedback from the... was it Formide? No, what's the company called? I don't know. But the Element, the guys who make the Element, like, yeah, great job on not reading the manual during the entire stream. And I was like, yeah, you know, it can get sort of chaotic. I get it. It's tradition. You know, it's part of the stream. Yeah, Adam Nozzleclock, that's the other thing. And like, I don't even remember that anymore. That was like midnight for me. Right, and now of course, since we're doing the Smoothieboard stream, we should do something exciting for Arthur, I guess. Engineers do not read manuals. No, engineers are the ones who write the manuals. Damn it. Alright, so that should not short out anywhere. It seems Arthur Wolf is gone from chat. That's okay. I understand. So this one. So this is the Y Max. Let's hook it up to Y Max. One hyperventilating. You got it. I mean, this smoothie board is sort of robust. I mean, I guess can't kill it. You see, that's the difference with a good versus a mediocre design. If you have a board that has proper protection in its design, you know, stuff that, you know, just safety measures against stuff going wrong or against people messing up, then it's going to survive something like this. I'm hoping it's still functional, obviously, but something like a ramps or something might be dead at this point. Right. So I believe we've established that the power supply is still pretty much functional. So let's turn that thing. If you actually plug it in. And actually, we do need to sort of short this one out. There we go. Because I don't want to boot it up with a half powered power supply again and do sort of like half flashes. There, okay, turn that on. Perfect. That's nice flashes. Yeah, not protected against everything. Well, you can't protect against everything unless you're designing like automotive or safety critical stuff. And even then, there is stuff where we're like, we can tolerate that. How often is that going to happen? Right. Where were we? We were at the point where everything went south. USB. Let's see if this should work out. Just plug this thing in here. Perfect. And we should be getting a drive. So, is that still plugged in? Is it? It's going somewhere, right? Hold on. So USB only, that's the plug right there. Now the question is, why is it not showing up in my... it is plugged in. it is not plugged in. Well, thank you for that. Yes, I was wondering why I was not getting any Windows hot plug sounds. There's that connector that we should put in the appropriate receptacle. Look at that, it's even working with just USB. Awesome. Cool. We've got a USB drive that is starting to show up. And that one should be here in a second. I saw it. We've got about 15 or 20 seconds delay between what I'm seeing in chat and what I'm seeing in chat and until you see my reaction on stream to it. So yeah, where were we? Okay, let's get back on track. We've got the most current firmware on here. The board is blinking happily. It is showing up on USB. It is showing up on, I didn't mean to press that. It is showing up on my laptop as a mass storage device, which is what we're wanting to get. And now I guess we dig through the config. So firmware current means everything is good. Yes, perfect. Now the Smoothie wiki tells me not to use Notepad++. It says, hey, Notepad++ is trying to outsmart me. I'm still going to use Notepad++, I believe. Unless Arthur is going to be all over me with caps lock and stuff. But I am going to use Notepad++, and it's actually telling me to switch to ANSI. And that's exactly what I'm doing. I also, the wiki also says, use gedit. Well, sorry. It should be good. It should be good. Use Notepad++ and pray. I don't know. Is there a gedit Windows version that I could download, instead of hoping for the best? Because I really like Notepad++. I mean, I guess Windows Editor does the exact same thing. As if we open with Notepad, yeah, we can still edit it, but I don't think that's like any better. It should be good. Yes, whatever. So let's just go with this. I've been editing the configuration for my Zabriskie board on ++. Anyway, so we should be good here. So let's just move through the entire config and drop in whatever configuration options we get. So feed rate 4000, seek rate 4000 should be good per arc segment. Don't care about that. Delta segments per second 100. Only segments and set as these millimeters per line segment. Whatever I don't need to change. I am just not going to touch it all. So steps per millimeter 100, 100 and 100. Yes, me is turning into Russian now. We are actually going to go into the Marlin configuration and just look at what that one is configured to. Right here we've got all the sections right there. All the delta specific stuff. Thermals, yes, we are going to need that in a second. ATC semi-text sort of thermistor. But let's grab these steps first. Steps. So 160. Alpha, beta, gamma, because they're all using the same motors and pulleys. We're just going to use the same value for all of them. My control button. Leave it as 100? What? Why? It's like, tell me 160 right there. Why leave it? Why leave it? What? Ah, okay, so that was recording that one. Okay, I get it. Arm length. Okay, so there is a formula on the Smoothie Wiki that tells you exactly how these settings correspond to these settings of Marlin. So we are going to pull up the Smoothie firmware, configuring Smoothie configuration file delta. Right, arm solution linear delta, we got that, linear delta, and we need arm length and arm radius. So arm length is from Marlin. Arm length is delta diagonal rod. So we've got delta diagonal rod 225.51. That sounds like a horrible, horrible non-metric number. And that was, just to make sure again, that was arm length. That's actually surprisingly close. And arm radius is delta radius, which is delta radius is smooth rod offset minus delta effector offset minus delta carriage offset. So, because I'm not gonna do that in my head. Wow, Windows 10, why are you so big? And why is my screen so small? Delta smooth rod offset. Delta smooth rod offset. Can I copy paste? I don't know. 196.85 minus delta effector offset, which is 39.11, minus, this must be fun to watch, watching a dude type in the values into a Windows calculator, delta carriage offset, 52.43. Boom, 105.31. So that's our arm radius, 105.31. Perfect. Point, not comma. German keyboard. Right. Good, got that. Planar cue size, 32 acceleration. Not gonna care about that. Junction deviation, not gonna care about that either. Base stepping frequency, max speeds. Yeah, should be good. All right. Alpha step pin, beta step pin, gamma step pin. Those are exactly what we were. Can I use my key hotkeys? I don't think so. Let's jump over here and then push them. So that's the exact alpha, beta, gamma that we're referring to here. As I've mentioned before, that directly basically translates to what we've got here: X, Y, Z, or alpha, beta, gamma. And then exactly those declarations are used for stepper modules, and yeah, exactly what we're putting in here. So max feed rates, not gonna touch that either. Baud rate, nah. LEDs, MSD, watchdog timeouts, not gonna mess with that either. Okay, hot end enable. Yes, so there's where the modularity of Smoothie comes. Sorry. I'm good. So there's where the modularity of Smoothie comes in. You can enable harden. You could enable another harden. You can enable, a bunch of Twitter. Shut up. You can enable whatever you want. So, since we have just the default setup of a single hot end, a single extruder. We're just going to stick with what's in here. So the only thing we need to change is the steps per millimeter. And that's 200 for this one. Default feed rate, acceleration, max speed. Doesn't matter. Extruder offset, that's only relevant if you've got multiple extruders. I guess you could use this to set the probe Z offset too, but that would be like a weird way to do it. Firmware retract, not doing that. Okay. Since the Smoothieboard does have the reference voltages of its stepper drivers connected to the microprocessor, we can actually set the currents for all of the stepper drivers individually. So whether it's the alpha, beta, gamma, or delta outputs, which is M1, M2, M3, M4 on the actual hardware. So again, these are labeled M1, M2, M3, M4 on here. They are referred to as alpha, beta, gamma, delta on the in the firmware configuration. Alpha is let's look at that. So basically, the way these delta towers work, because you don't have XYZ per se, you're still calling your motors XYZ because that's what most main boards are calling their power outputs. So alpha is this one. Alpha is this tower, so this motor and everything attached to it. That's the alpha tower, and also the one on top here is the alpha end stop. The beta is this one over here, so front left, then front right is beta, and then the rear pillar is your gamma or Z, basically, tower. Yeah, it doesn't matter which one is which exactly, but you are going to have your print volume rotated if you mismatch them. So if you rotate your model facing you, it might end up facing out the back somehow. Yeah, tuning offsets, I don't think I'm going to do that. I'm just going to leave that to the Smoothie automatic procedures stuff. So yeah, 1.5 amps, that sounds plenty for the motors. That would, I'm actually going to take that down to 1 amp. And also up here, because these are not high current motors. They do look like super beefy, but no, wrong one. Up. Wow, they can't do anything. These motors in here do look super beefy, but they are not high current motors. They are high inductance, high resistance motors, so they are more or less made for high voltage drivers and not for high current ones. Let's just see how well they work out with the Smoothieboard hardware. So I think they're rated around 1 amp. I'm just going to go with that. That should be more than plenty. To exactly the rated value, so the way I keep doing this, the way I understand stepper motor current ratings is basically that is simply the current where it will rise, I don't know, 70 or 80 degrees above ambient. So if you are driving it with a full 1 amp, then it's going to heat up with 70 degrees Celsius above ambient, which is 100 degrees Celsius, which is still below its 120-ish rating typically. But at a lower current, I think they should work just as well too. Sometimes stepper drivers don't work well with specific motors with specific current settings. So it's more or less just something you can sort of try out. Yes, never go higher. Obviously, yeah. I mean, maximum current, one is heat, the other is also magnetic saturation, which would be too much to explain. But once you go into saturation with these, you are getting no more extra torque and a bunch of heat. So don't really want to do that. So 1 amp, you should be fine. We're still on screen cap. Perfect. Laser module. Again, modularity. We're not enabling the laser module. We could pop out the hot end and drop in a laser. No problem. Smoothieboard does support that. So temperature control, hot end enable. Yes, we do have a hot end. We also want it to be temperature controlled. Now, thermistor pin 023. Let's check if that lines up with what we actually physically connected it to. Where's my reference? Nope. Where's my reference image? Copy. Yeah, and there's almost no reason to run your motor at a higher current than it is rated for. If you need more torque, just get a beefier motor or a potentially, you know, a better driver, which is my preferred option of getting more torque from a given setup or a given combination of motor plus driver, because, you know, different drivers like the trinamic drivers can make a huge difference in your torque output and consistency and resistance to losing steps more than you'd think. The trinamics actually, in my experience, have more torque or a more reliable performance at higher speeds or at the same speeds than both the DRV, the Texas Instruments DRV drivers, or the Allegro ones. Yeah, so 023. That's our T1. That's exactly where we connected our... Hey, we have webcam. Cool. That is exactly where we connected our thermistor to, right there on the very edge. So that's P23. Yeah. P23 got that hot end heater pin 2.7. Let's also double check that against the wiring diagram. So we've got 2.7 is the other one. So that's, so 2.7 is what we now have the, bed heater connected. So we are going to change that simply over to 2.5. And once we get to the heated bed section, we will change that one to 2.7. Or we could just flip the mechanical connections, but nah. Thermistor, EPCOS 100K. Now the thermistor we have is not a EPCOS 100K. It is a ATC Semitech style, or I mean at least using that temperature curve, I guess. That's what the original Marlin Fairbairn configuration suggests. So we are going to grab one that sort of matches it there, Semitech. That's the one we want. So because Arthur is asking about the MOSFET wiring, so basically, or the solid state relay wiring. So basically, all that is it is connected to that to this one. Wait, did I? There. So this one. It is basically connected to the MOSFET output. That should work. That should work exactly like that, because this is getting the this is completely insulated against everything else. There's just an LED in here, and it's grabbing the 12 volts from the output. That should work. Why is that not good? Why is it not good? It's completely insulated from anything. Some SSRs don't like that. Okay, well that's exactly how it was set up in the original Atom hardware. It was also just connected to the nothing on there. Fan heater bed. So it was just connected to the heater bed output right there. Basically controlled by an exact type of MOSFET. I can see how it could be a problem if ow, those corners are sharp. I can see how it could be a problem if you've got your SSR not insulated from the rest of the machine on the input. If the SSR itself is not insulated, but like this is should be fine. Should be fine. Semitech. That is our thermistor of choice. Ooh, vertical scrolling. So hot end thermistor is this. Crap, that didn't copy. Semitech. That's the curve from the Semitech thermistor on in the hot end itself, which is a through-hole type, but still using the Semitech curve. So more modularity, more than some people need. So we are using the M104 M code and the one M09 M codes to it's case sensitive. Oh, got that. So what? Wait. Why is it saying? Oh, it is not. Oh, okay. It looked like it was all caps. Yeah. So you typically have M109 and M104 set up for your hot end temperature codes. But you could use anything else. You could use M105 if that's your thing, or anything else. But you know, we're just gonna leave that at that because it would break a few things if we messed with it. Hot end 2, we could enable this. We don't want to enable this. So I guess by default now it's set to bang bang temperature control mode. We P factor, yeah. So I do believe we can. Well, let's just set min and max just to be safe. I do believe we can set this afterwards through the terminal and have the hot end tune in itself. Because at times the actual PID values from Marlin or from a different firmware might not work out perfectly for another firmware because the scaling's different, because the tick rate, the temporal time basis for that is different, and I don't just want to copy paste this over. I'm actually going to tune in the hot end on the I'm going to tune in the hot end on the printer itself. Yeah, temperature control hot end 2, we don't need that. Bed enable, okay, that's where it's getting interesting. Let's just go to thermistor again. There we go. So temp sensor bed is a 100K EPCOS 100K type. Let's see what Smoothieware has in stock there. EPCOS 100K. Okay, so this one is all caps. That is, you know, slightly inconsistent. What are we going to see? There. EPCOS 100K. More delay? I don't know. I can't judge delay at all. Unless I'm actually looking at the video, which would be boring to watch, I guess. So, same here, we're doing control bed designated, so B, yeah, that's good. 104, 109 is fine. So, fan enable. This is our part cooling fan. So, part cooling fan on, 106 off, 107. That is exactly what we want to do, and that is exactly what most slices will be generating by default. And by default, this one is also configured to PWM, so we can actually control how hard these fans are blowing how hard these are blowing against your print and over your print, basically. Let's just double check that this is the correct pin, because we have two different fans, which we will, yeah, that's right here where we will set up the hot end cooling fan to automatically enable above a set temperature. Now, this one is set to 2.4. Temperature switch, hot end, switch misc. Okay. Got that. So 2.4 is the suggested one for the hot end fan, and 2.6 for the part cooling fan. So let's check this. So 2.4 is the one closer to the connectors over here, which is our part cooling fan. So we've actually got these switched, 2.4 here, 2.6 there. Bed PWM frequency 20, sure. Where is that thing? PWM freak. Do we need to add that? do we actually need to add that to the config? I'm just copy and pasting that, or copying that for now. Actually, one thing we missed was this one. Nobody noticed that. Why did no one notice that? We did need to switch these over for, you know, between the where the hot end is connected and where the bed heater is connected. And you know what? I'm just gonna switch the I'm turning the recorder a bit. There we go. So it's not like this weird one-eared kind of thing. Right. Temperature control, bed, bang bang, falls, fan. Okay, so let's add that just. We're still in the commentary. Crap. Let's add that here. Bed PWM frequency 20. Bed heater pin good, yes. Check that. 2.7. That's what we need. 2.5 is the hot end. We've got these switched compared to the default. Let's move on. Fan enable. Okay, so we got 2.4 as the fan. We've got PWM enabled. That is good. PWM should work for both the SSR and the hot end, as well as all fans. That should be perfect, because the SSR, it's not an AC type. It's not switching AC. It's just switching regular 12 volt DC. So it's not really needing a reset point that is like fixed to a certain waveform of the input. So what I just enabled was I created, let's go through these settings real quick. I created a new switch type, so that is basically a module switch that he enabled. It's called MISC, and that one sits on 2.4, and it's a digital, so an on-off switch basically. And again, we can enable that with M42 or M43. I don't think that's used for anything else. I mean, you could manually turn that on and off, but we are also switching this switch.misc with this temperature switch module. So we've added the temperature switch module right there. We're referencing it to hot end. It's running off of the hot end temperature. We're enabling it. We're looking at the T temperature, and we are switching the MISC switch with that. So basically, at 60 degrees Celsius, this block right here, this temperature switch module, will turn on the switch.misc, which is our hot end cooling fan. Wow, that was tough to explain. But basically, that's turning on the hot end cooling fan by itself automatically, and yeah, keeps the top hot end nice and cool. Right. End stops. We don't need a spindle. We don't need a CNC mill spindle right there. End stops. Enable it. Yes, we do have the end stops. We also have a delta, which means we're using the delta homing. Alpha min, none. Beta min, gamma min, none. We don't have any minimum fan. I'm reading fan in chat. We don't have any minimum end stops here. We only have the maximum ones. So we don't need these, but we need the maximum ones, which does correspond with what's written on the board. So 125, 127, 129. Those are the pins of the physical end stops that we're connecting right there. So I'll need to check the end stops with M119. Yes, I definitely need that. And whoops, nope. And in fact, that is on the to-do list of firmware configuration. Yes, I'm checking them before I'm using them. And what we're basically doing here now, this symbol right here, this does that symbol have a name? That basically enables the end stop, the pull up for the end stop. So what I explained like 2 or 3 hours ago, where there is no progress. Okay. Where I explained that these switches are only using 2 wires, one for ground and one for signal plus a pull-up. That is exactly where this comes in. This is where the pull-up gets enabled for that exact switch. Carrot symbol. Okay, carrots. I like carrots. Very, very good. Right. Max travel. Gamma max. Okay, I guess we should set the Gamma max first. Max travel in millimeters for alpha when homing. Okay, so these are just safety features, so it doesn't like try to home forever. And this one is the one where this is basically going to be the z coordinate that the printer will end up with once it homes all the way to the top. So when all these are up here, all the way, click, 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 then that is this exact position of 300 right now. And it should be in the Marlin default configuration as well. 150. It's X, Y, manual Z, home pause, okay. 360, perfect. You just use that exact setting. 360, there you go. Fast homing rate, slow homing rate, that's perfectly fine. Retract, cool. Weird trims, that's going to be all going to be set up like that, and set up by the auto tuning system. Fast homing, slow homing, perfectly fine. Z probe. I actually want to not configure the Z probe right now. I actually kind of do not move the motors by hand. I actually do not want to enable the Z probe for now. I just want to check the basic functionality and then enable the Z probe after we've got this done. Kill button enable, panel falls, got that. Panel menu offset, panel custom menu power on. So M80, M81, we could set up a power on switch, and if it was like 3 p.m. right now, we have hours and hours to go, and I would have set up a power on switch for this, but I think it's gonna just, put it in a separate video and make like regular content of that, because I think having M80 and M81 turn on an ATX or a brick type power supply like this could make for some interesting content. Current control module enable true, yeah. Return error on underlying network, enable false. That's also something we are going to enable after we get everything else set up. So for now, I won't break it. Arthur, are you sure about that? Are you really, really sure about that? I wouldn't be. Right. For now, we've got everything set up. We've got the motor set up. We've got the steps per milliliter. We've got both heaters set up. I am looking forward to see if it will actually return a min temp error for the heated bed, which is not connected right now. But for now, we should be good. We can apply this, we can save this thing, eject it, reboot the machine, and then see if it works. We're just going to stick with USB and control the machine through this. Yeah, for braking motors, the service report, I've pushed that thing around a whole lot. It's got standard motors in there, low inductance ones, but they are holding up fine. And the original MKS board, which also just has like regular Polulu modules with with zero protection. Yep, zero protection on there, zero extra protection. Have also so far kept up well with my abuse of this machine. Right, save, I guess. Save. Done. You know, the USB interface to SD is not the fastest thing to do, but it's more comfortable than ripping out the SD card every single time. Right, reset command. Let's do that. We are looking for pronter there. Pronterface. This is actually the pronterface that the Prusa Mark II came with. Very thankful for that because the regular pronterface does not work on this machine. COM7, I think we can connect with any baud rate, but come on, just stick with that. I have no idea if it's COM7 or COM4. COM7 works. There you go. Yeah, disconnecting the motor while they are powered up. Not cool. Really, really not cool. Right. Reset. That's how it works, right? There we go. Reset. Smoothie. Is that how I'm supposed to do it? Smoothie? I don't think that's how it works. Yeah. So if we've got, I guess I should eject this thing as well. Let's just do the actual physical. You get inf on the bed. You get inf on the bed? Inf on the bed, yes. Reset. I get inf on the bed. I do get inf on the bed. That is true. I guess that means I should be like physically connecting the thermistor from the bed. That should work. That's better. Right. I mean, I was sort of expecting that. I'm not sure if that. Yep. I'm not sure that. I'm not sure whether that actually stopped the firmware from responding or anything, but let's just connect it and get it over with. Come on. There we go. Okay, let's put heat shrink on this thing right away. At reset. Okay. I was wondering why it just responded with smoothie. I guess that's a cute response and all, but you send it reset and it says like smoothie. It's like a little Pokemon. knowing one word and one word exactly. Smoothie. Whoops. Hot and punctures the smoothie board? I don't know. Well, the thing is, the power supply has pretty big capacitors, so even if I shut it off, it's like, it's not quick. Smoothie man. Smoothie man. Smoothie. Right. We do still need to plug it in. That's the other thing. Someone asked about the aluminum bed that I believe the one I'm using on the Zabriskie board. So the Zabriskie board has a 6 millimeter thick milled aluminum plate, which is awesome, which is super flat and all. It works pretty perfectly. Plus a 600-watt silicone heat. No audio? I got audio. And a 650-watt silicone heater. But you know, neither of those was like particularly cheap nor particularly expensive. So they're like, sure. Unplug this as well, I guess. The silicone heater was sort of like $25 or something from AliRubber, but they sent me two, so I now have two of those. I ordered one, I got two, which is good because I messed up the heater on the MK2 live stream. So our print run is driving you nuts? Well, let's connect then. If we can get the right one. Could not connect. I guess I gotta wait for it to show up. And that was COM4. What? As I was saying, the silicone heater was like $25. The aluminum plate was about that much, and I cut it to size with a jigsaw. So that, yeah, $50 for the heated bed solution for a 30 centimeter inner diameter hexagonal bed is okay. It's not the cheapest, but it's pretty darn awesome. It's like super. It's super fast. It's super accurate as far as the surface quality goes because it's actually milled. It is an awesome thing, and I'd do it again every single time. Right, we are connected. We are printer now online. We've got a reasonable temperature for the hot end. We've got a reasonable temperature for the bed. That is great. Let us check the end stops because that's like the first thing we should be doing right now. 111, so they are all triggered, which makes sense because I've pushed the carriage all the way up. Let's just pull this very, very slowly down. And let's try that again. 0, 0, 0. So the end stops are working. No. Right, end stops are working. That is good news, which means now I can turn the power on and check if the heaters are actually responding properly to what I'm sending them. That's still going. Let's give it a 210 for the heater. And let's see if this heater responds really quickly. Yep, so that makes sense. Heater works. Let's try the heated bed. The heated bed has a that's the fan from the power supply. The heated bed has a PCB stuck to the underside of this aluminum heater and a thermistor soldered to that exact PCB. No, that's not the that is not the power supply fan. That is the fan here in the carriage. Yep. So that's working. Thermistor for the okay, so the heated bed doesn't look that happy. Let's check that. Bed isn't rising, yes. So minus there. Oh, I might have. I talked about it too. Yeah, I talked about it too, yeah. So this one has positive up top, negative down here. So I sort of mixed those up, and now we get minus 12 volts to the SSR. I guess I'll just have to swap those around, and we should be good on that front. Better getting colder, wrong polarity. Yeah, that. So that's gonna be something I'm gonna be doing the next time we power this entire thing down. For now, I do want to try to send it a G28 and see if it actually homes correctly. The good thing about this magnetic coupler, or this magnetic setup with the come here. With the magnetic rods in here that you can, just snap in and snap back out, is if it should crash, if it should really crash, chances are these are going to come loose and protect anything bad, protect it from actually going through the board. The board does have a bit of stiffness before anything breaks. So yeah, let's just home this thing. Well, if maybe not. Okay, let's do this. Let's do this a bit more slowly. So it's saying it's thinking it's where are we? There. It's thinking it's at 000 position. So the logical thing to do right now would be to actually move it up a bit and see which direction it moves. It moves up. Ooh, that sound. I do suppose that is the combination of the motors plus the drivers, and this thing is quite noisy, which makes me both as far as running it goes and as far as the idle noise goes. So I guess that is an indication of how much current we are actually supplying to the motors, which I guess would be quite a lot the original board is doing. The noise isn't that bad. The Dynamo 3D was much worse than this. This is just like a consistent noisy kind of thing. It's not like a where's our motors off button? There you go. It's not a consistent whine. Mic cuts out now and then? What? Nah. It's not like a consistent whine or thing. It's like, it's more of like a windy sort of noise. But we are going to turn the current down. For now, before we do that, let's just home this thing and see what happens. Shall we? Okay, that works. I guess the feed rate is set quite high. I mean, let me just try that again. To give you a better view of it, obviously. Alright, 3, 2, 1. Yep, it homes. It homes pretty much perfectly. Awesome. That's good. It might be, it might be the slightest bit too fast. It might be the very slightest bit too fast for the homing procedure, but it does home. It sounds a bit rough, but it works. It works. I'll have to see how fast it actually is. But I mean, realistically speaking, there's well, it is going to slowly hammer the top vertex up, but it's not actually hitting the switches, it's hitting these acrylic blocks. So, yeah. Right, we got that. Let's check the config again and maybe slow down the... oh, cool. Maybe slow down the home feed rate and turn down the current. Those will be the two things that we should do first before we dive deeper into auto, into the probe and all that sort of stuff. Yeah, I could launch an object into orbit. The interesting thing is how fast this actually works. Right out of the box, you know, I get it. The motors are getting huge amounts of current, but it's fast. I'm wondering, is there a micro snipping setting on the smoothie board? Always just had this on 16 or default for my configs. All right, current. Let's turn that down to like 0.5. That should be more than enough. And if not, we can always turn it up. Turn up for what? You might ask. Well, come on. Delta, where's our delta? There's our delta. Fixed to 1/16. Okay. Right. Let's check home. So homing, fast homing rates. Let's just take a 0 off of each of those. Millimeters per second. 200 milli... What sort of defaults are those, Arthur? Why do we have 200 millimeters a second default homing rates? What? You might want to work on those. I'm okay with it, but chat seems to be sort of upset about the level of speed we're doing here. But 200 millimeters a second. I thought those were millimeters a minute. Let's turn those down to like 50 or something. That sounds reasonable. That's faster than most of us print. It does work, yeah. I see it works, but right. So homing feed rates, we got that fixed, and next up the motor currents, we got that fixed as well. So let's close this one. We're not going to be needing that anymore. Let's do the Z probe. Let's set up the Z probe. So on the on this carriage we have this one mechanical switch that works exactly like all the other switches that operate the end stops on alpha, beta, gamma, or XYZ. Up here, the exact same type of end stop or micro switch, and here it directly triggers to the bed probe. The thing is, before we actually start messing with that, I do want to get the bed back on here, because if we start probing and like I don't get to trigger it in time, it will probe into the smoothie board, which like I said, it does work, but I don't want to measure out the surface of the smoothie board. I know that thing is sort of flat. I actually want to measure out the surface of the bed. So let's get this stuff back in here. The one thing I've been looking at and wondering if it would work is that is sort of loose. The heated bed clamps right here. These actually have these long screws that actually go down into the electronics compartment. I think there's one more thing we need to do. I think we should clear the all the components in here pretty well. Only one LED will come on. I don't know. Sounds like fun. I will need, at some point, I will need to grab this 32 gig SD card from the smoothie board. Not right now though. The good thing about the Atom 2.0 right here is it is easy to open up, just these 9 screws right here, and you're at this point, and it is easy to reassemble, so at any point I can just reach in there, grab the SD card, put the default back in. But right now I don't want to mess with copying config files back and forth. That doesn't sound interesting to watch, so I don't want to put you guys through it. There's one SSR pull. What do you think I'm doing right now? Is this not switching the SSR polarity. Actually, right now it is on. So we still have the tire machine powered up. Yes, that is like the ideal condition to start screwing around in it. Power, yes, power off. That would be a better idea. But right now we can see this thing is lighting up. You can see the LED right there, and the screwdriver sort of reflects it right there. That thing is powered on. No, we don't get smoke. Trust me, I'm an engineer. Let's reconnect real quick here into the face, and we can see the bed is rising. We're at 39, 80, 31, and so on. So yeah, we are good here. This portion works just fine. Perfect. Trust me. We're fine, guys. We're fine. Right, let's just disconnect this and actually turn it off right now. Unplug it, and just because I don't know what all the things are going to be that I'll be smashing when reinserting this heated bed. Oh yeah, and it is warm. So the measurement is actually correct and not just a fluke. And the problem here is it is sort of tricky to like really get these in here the way they should be, because you have to take care of the belts. Like that. And I guess watching the screen cap is like there. That's a bit of a better view. There. All right. Let's see. Let's make sure that we're not smashing any wires right here, because that would be bad as well. We're going to be screwing this thing down pretty tightly. But so far that looks good. Perfect. It's going well. It is going absolutely well. Right. Screws. Where did I put them? There. So there are these screws down here. Now I did notice I actually moved some of these drop-in nuts. Oops. A second ago, so let's see if all these are still aligned, and this one is in fact oh, it is. This one is aligned. Good. Good here as well. It's looking good. Okay. Yeah, I mean when the heated bed is on there, it's like it looks like. Okay, Joe, it is a professional job. It doesn't just look like one. It is an absolutely professional job, isn't it? I mean, it's like it's fully functional. We've got the USB plug working. We've got Ethernet not plugged in, which I realize I'm an idiot for not doing, which I'm going to do right now. Yeah, but the actual outside of the printer, other than the dysfunctional LCD panel up here, is like. That's the one thing where I guess you could tell that it's not stock like this. Once I don't know if you're gonna have time for this, but maybe we'll try. Putting the LCD, putting the Android tablet on there, and actually having it connected to Wi-Fi, and the Smoothieboard to Ethernet. I guess. That's gonna look a bit suspicious, but as far as functionality goes, that's gonna be just fine. Right, get the screws undone. Can we fit this one through here? Oh crap. It appears we actually need to remove a bit of this Ethernet cable. And what better tool to do that than the tools that actually came with the printer itself. Look at that. Talking about professional. This one goes in here. I know you could put like a professional Ethernet extension jack thing in there. I actually do have one of those, and it's mounted to my Mendel 90 right now. And you know, if this were like a thing that I do like once and then be done with it, then yeah, I'd probably get one of those. But since I am going to be removing this smoothie board from it in a couple months, anyways, this will do for now. So tight. And also upside down. There we go. Okay, now we've got it all. So that's a 10-meter Ethernet cable that's going to a switch in the corner over there. That switch is connected to the home network, which does give it internet access and all that sort of stuff, and also allows it to talk to the other devices on Wi-Fi. So our Android tablet that we will, if times, you know, if the time is still enough for that, we're gonna try to set that up with Fabrica and replace the LCD with that Android tablet. Yes, I will have to rebuild this for the what's it called, Atom 2.5. I don't want to say upgrade because it will have the original board in there again, but for the original 2.5 hardware of the Atom, from the Atom guys. So I will need to put the MKS baseboard in there. Okay, I don't know, maybe not. Maybe if it's mostly a hardware upgrade, I can look at the hardware without actually changing the board back. We'll see. But obviously, I mean, the smoothie board should be in here. That's where it belongs. Right. Those two, and let's get the rest in here. 2.5 differences. I don't think I can talk about those yet. The things I can talk about should be in the review. I did comment on them. I did comment on what I was allowed to say, I believe. But yeah. Silky board. Smoothie V2 is better. Cost radius of that delta. So again, watch the review. That would be like my first recommendation. The Atom 2.0 is a 220 millimeter radius build volume machine. Height is 360, I believe that was the thing, but actual usable height might be a bit less. It's 1,699 without a heated bed, without the shell on here, and without the spool holder on top. So once you add those, you are easily past 2,000 US dollars plus tax and shipping, which is a bit expensive. I mean, the hardware is pretty awesome. It's got the linear rails, it's got carbon fiber rods, it's got, you know, all these premium mechanical components, but just having an MKS board and that simple LCD screen. I mean, the Prusa has the same LCD screen basically, but then again, the Prusa is like 1/3 or less than 1/3 of the cost of the Atom. So, you know, always have to look at what sort of a bracket you're talking about. Right. Otherwise, it's good hardware, let's see if the Smoothieboard makes it better. I would have opted with 0.9 degree motors. I do have 0.9 degree motors here. I will try 0.9 degree motors in this machine, but I don't know when exactly. Right. Good. Got that closed off. Let's put the glass on there to give the... I just realized I should have tested the Z-probe before this, but we're good. We're good. Good. Now, we got that. We got that. Okay. Let's set up the Z-probe. So the Z-probe is configured. It doesn't exist anymore. Let's recut all this. It's hard to pick up and get back to this screen cap. Nope. Let's reopen that. Oh wow! Come on. That's while the drive shows up here. How long do I have left? When's the Google Hangout? So yeah, for my Patreon supporters, there is going to be a Hangout in 2 hours. It is currently 6 p.m. Hangout is starting at 8 p.m. We're doing another Q&A Hangout, so for everyone who's here and wants to join after that, I guess, Patreon. That's the way to get in on that. Yeah, that's that's my monthly, or now I guess I'm splitting the Patreon Hangouts up to 2 Hangouts, because I've had a few where I guess it was in the wrong time zone stuff, where no one was there, or 2 people or something. And then I was like, I'll try in another time zone. So now I'm doing one in the morning and one in the evening, just to give a few more people the chance to join in. Right. Z-probe, there we go. Okay, Z-probe enabled. We are true here. Pin 128, that should be good. Slow feed rate, so this makes a bit more sense. So 5 millimeters a second, that works. Debounce count, don't need that. Fast feed rate, 100 millimeters a second. This I'll set a bit lower, because this one depends on having the so this one depends on having the the height set up correctly for the maximum height, basically. So it starts at the home position at G28, basically. This is all the way up, and then it goes down to the bed, goes down the fast speed to 300 or something, and then goes the rest of the way slowly. Was not safe before. Oh, okay. Thanks for the hint, chat. I definitely didn't save that. Yeah. Where are we here? 0.5, which means we should also update the homing feed rates again, I guess, or not. We could just leave them that fast. It works, right? Again, why are those defaults 200? Okay, so we've got the, where are we? We've got the Z-probe enabled. True, that Z-probe is connected to Z-min, which is the 128. inverted pulled up. I guess we need to uninvert that because it's the same type of end stop as the others. Slow feed rate 5, fast feed rate 20, height 5, so it travels down to 5 millimeters above the bed and then goes the rest of the way to the bed surface. Let's see if it, ooh, is my light flickering? Uncomment the leveling strategy while you're at it. I will do that in a second, or actually I'll do that right now. So it will never get there. So the yeah, the Patreon tiers are $5 a month for the Hangout. But as always, Patreon is not about paying for services. I mean, you can always book me for consulting if you want to do that. But Patreon is more about saying thanks, giving appreciation for whoever creates content, and it shouldn't be about the rewards you're getting, I guess. Yeah, all right. Leveling strategy, delta calibration, enable, and the radius. So Smoothie does have a few different ways of calibrating delta and calibrating your bed, basically what you'd call auto bed leveling. Yes, you can cancel Patreon at any time. It is a monthly thing, so unless you cancel it, it is a monthly pledge to creators you want to support. But you can cancel it anytime. It's not like a 24-month subscription thing. Yeah, configure networking. We're going to do that at the very end. Yeah, for now, do I want to enable this? I guess, yeah. So 100 millimeters is actually pretty okay. We got 220 usable. Let's bump that up to 110 just to get the maximum build radius covered, because anything outside of that radius will not have pretty or will not have decent accuracy. That's what I was going to say. Yeah, if you're looking for consulting, shoot me an email. The email address is where would be the easiest thing? Tom@tom3d.org. That's like my main business address. If you want to get in touch with me. Right. Also, oh, I missed two. Also, 8 years 96 from Frank Kinkel. Thanks for the inspiration. Thanks for the donation. Always appreciated. Very generous of you. 10 years from Mudhen. Ich habe nach deinem Test auch ein Smoothieboard von Zabriskie geshoppt. Ich warte noch darauf, in meinen Micromaker Delta Print eingebaut zu werden. So danke für diesen Stream. Liebe Grüße from Austria. Okay. German. Yes. We're all Germans now. Yeah. Or Austrians in that case, so thanks for that. Also appreciate it. And glad you went with a smoothie board. That is something I'd recommend in any case. Right, let's move on. Leveling strategy, delta calibration, true, enabled radius, got that. So we've got the delta calibration available for us now. And I just thought I did make a mistake right there. The delta calibration should be at the center point between basically your bed center. Let's just swap that back here. Right there. Between the bed center and your actual columns. So you don't actually want to probe at the very edge of the board. You want to probe between the carriage and the pivot point basically, and your center point of the bed. So that would be like 80 millimeters, more or less, or 75. Yeah, that works too. Let's make it 80, because I say so. Right, save, and we can run the delta calibration like that, I believe. network. We're going to configure that once we need it. Save, eject. Is currently in use. Yay. Try again. Perfect. So if we head back here, if we connect, so we should be able to do a add reset. Smoothie out, peace. Putting in 5 seconds. Can't read from printer disconnected. Okay, so that one is properly disconnected. I might need to actually restart that one until the card shows up again. Come on, I know you're gonna show up. Where art thou? And I guess I will physically replug that. Whew. Micro heart attack for me there. There we go, there's the USB drive. Which means we can get Pronterface to connect again. That's always like sort of thing with smoothie boards. You do need to wait for the USB initialization to finish, and then you can connect. There we go. Print is now online. Temperature is still okay. Let's try homing it again. Let's try moving it down a bit. That works. So noise is a whole lot better. It still sounds a bit rough, to be honest, which might just be the motors. But let's just see how this thing homes. Much better. Actually sounds reasonable. And now we're getting that high-pitched whine, which will pick up on the microphone pretty well too. So unfortunately there's nothing I can do against that right now. Wow. Yeah, I don't like that sound either, but it's just something that comes along with the motors in combination with the stepper drivers and the chosen supply voltage. So probe is at 0. Nope. Huh. Got my hotkeys on 6 and 5. So if I trigger the probe and send that command again, we're getting probe 1, we're getting probe 0. So the probe is working, which means we should be able to do a what is it? G30. G30. We're gonna hit that off after we switch to that perspective. Let's see what happens. Okay, so there's the 20 millimeters a second. I guess we could have done that a bit faster, but I guess better safe than sorry. Should I trigger this? Maybe. Just to be safe. Now it's moving all the way back up again. Okay. Yeah. Yeah, so Smoothieboard does this thing where it probes with the fast feed rate until it gets to like close above the bed, then does the rest of the probe with a slower feed rate, and then goes all the way back up again, which if you have the feed rate set relatively slow, that yeah. G30 Z0, yes, but not with that pace. Before we do that, I am going to Before we do that, I am actually going to pump up the homing speed on. There we go. Pump up the homing speed on the Pro, because if we do the auto calibration, that is going to take quite a while because it's going to be moving up and down quite often. So where are we? Pro. Fast feed rate 20. Let's bump it up to, I don't know, 100. Let's do 100. Let's get this one a bit further up. Yeah. So the question is, does G29 not work on a Delta? G29 does work on a Delta, but not with every firmware. Smoothieboard does support a G29 mesh, or what's it called, grid leveling, whatever, approach, where it probes points just like the MK2, and then compensates for each area between those probe points. Other firmware support 3-point leveling, but G29 does work on a Delta. It just depends on which exact firmware and configuration you're using. Right, 100 millimeters, 10 millimeters, leveling strategy, true. So I guess that is what we will need to do next. We got that saved. We got that ejected. Don't want to click the wrong one there. And because the reset actually didn't work all that well, we're just gonna physically replug that. Wait, does that actually reset it? Actually, it shouldn't. Yeah, so people, every time, like, people are asking about Nightbot. What the hell is Nightbot? Why aren't you on Twitch, Nightbot? Nightbot is not a person. Nightbot is a bot that the same guys that make StreamTip make, and basically he's like an automated moderation tool thing that you can either use with your Twitch chat or with your YouTube chat or YouTube live chat, and you know, he gets triggered by keywords, by all caps, by emoji spam, by basically whatever you configure him for. And yeah, Night Dev, that's the guys, and he basically does the dirty work for moderating a stream like that. Right, we were still connected. Wow, printer is now online. Okay, let's try the G30 again. That's not faster. Oh, Nightbot was a real person. No, Nightbot was never a real person. Never. On no stream, nowhere. He wasn't. So it should slow down. It did not slow down. And we are getting a whole bunch of vibrations. The entire table is vibrating right now. Right, so did we get a feedback on where it triggered? What? 171.4. Where are we? Where even are we? Why are we at Z0? We're at 355 because bounce back 5 millimeters. Okay. Fast feedback is XY move rate for calibration. Ah, okay, so I guess we can do calibration. And use that. Alright, so next up, and I think that is going to be the last thing for today, because we are both running out of time and I'm running out of voice. we are going to set up the Z probe or run the Z probe auto delta calibration and have that basically measure out all the deltas dimensions by itself and set those to what you see what I'm talking about, and set those to what the Smoothieware thinks is more accurate than what you actually set to it in firmware. Right, this not disconnect, motors off, just to get rid of the whining. No frog, unfortunately, no, not today. Humming was with the correct speed, yes. All right. And now what we need to do is, so we've got G28 that works with the correct speeds even, and we got. Can we print something while the Hangout is going? Maybe we could. Let's try the G32 because a small print should work without the auto leveling all set up. Before we jump into G32, let me just see if we actually have the steps per millimeter set up correctly, because that was looking sort of janky for me. Let's just move to, let's turn the camera off. Let's move to the G0Z200. That's not correct. That is not 200. Because if we send a G0Z300, that should move up by just 10 millimeters, but that's 20. That's a lot more than 10. Waldemar, thanks so much for the Patreon pledge. That is always appreciated, and I sort of always mention it in the Patreon Hangouts, having that, as a freelance artist, basically, sort of just having any monthly income, anything that's like consistent. That is so awesome to have, and every single pledge is part of that. So much appreciated. Thanks a lot for that. I'm gonna get a measuring tape, a ruler sort of thing, because this. Alright, let's jump back here because the distances aren't right. Was the MKS 132nd? Whoops. And check. So we've got all three jumpers in there, and these are. Ooh, okay, I see now. I see. There's the problem. There's the problem. If you can read that, 8825. These are DRVs. These are TI drivers. All right. That explains it. Which I guess is an easy fix. So jump back in here. Why did I refresh the stream page? Basically steps per millimeter. So are we unplugged already? No, we are not. Okay. So steps per millimeter. Just to half that, so 80. Let's go. Okay. Was this a live stream? Yes, it was a live stream. I don't know. Should we print something? It feels. I am completely out of energy and out of voice, but I feel like we do need to print something before we call this one quits. We do have power switch, right? There should be some readily sliced files on the SD card in the original controller. I'm just going to look through those and see which one of these works and pick one and print that. Does that sound like an idea? Don't forget the extruder, Tom. Oh, the extruder. Yes, the extruder. Good point. Thank you for that. Well, until this thing loads up. While we wait for that, that's also a lot. Is that faster now? No, it's slower. So if we go G0C300, that works out to the correct height. And then if you go to 200, we should go to about here. Yep, that works. Perfect. You can set those things with G-codes that you will also see documentation from if you run M501, M503. Cool. Doesn't do anything though. Just stop the printer. Haha. Right. Disconnect this thing. Printer face crashed. What? Chat, what did you do? M503. That didn't do anything. Let's see if we can still connect. Nope. Okay, that's off. Right, let's get out of here. Nope. So extruder steps per millimeter. Yeah, needs 500 before to get the override settings. So that would have been the reason why this thing just crapped out on me. Right. Let's see if we can get the. That's not good. There we go. There's the drive. Once that shows up, we can check the extruder steps per millimeter, and then just I guess we're just gonna go for it and mod a G code, print that. There's still some magic glue on there. I think I'm just gonna put some fresh one on there and see how it works out. Leave you guys with a nice view of that print, and yeah, sweet. What are we doing here? I don't know anymore, guys. I have no idea what we're doing here. But apparently it involves a Smoothieboard and like electronics boards and like firmware configuration and that sort of stuff. Unfortunately, my laptop is like completely giving up right now. What is happening? What is happening? Shut the fuck up, guys. That part. My PC is giving up. We're 100% CPU. We're not getting any drives to show up. Okay, this is not working out too well. Anyways, how are you doing with Nightbot? Anyways, yeah. So That's I was gonna call it quits there. Wait, let's run the auto calibration. Try and print something and then get out of here. All right. Steps for delta current or extruder basically. There we go. Extruder steps per millimeter, so that 200 is default, 100 is what we want. Save that. Eject that. Perfect. My PC is showing me, yeah, it looks like it. There you go. Replug the printer. Perfect. That's reset. I'm just, by the way, if you guys are wondering why I keep looking into the bottom compartment, I'm checking for the red LEDs on the smoothie board to turn off. Just to have that complete power cycle, to have the smoothie board actually in full reset and, discharge, the power supply discharge, the smoothie board reset before we actually get in and do something else. Right, pronto face. Yep, so that's there. Connect. Now if you do a G30, that thing is going to move down very, very slowly. Yes, I just corrected for the microstepping on the extruder. And I don't really want to wait for that. Let's M500. Why the smoothie board and not the new Duet? Why? Well, because I have a smoothie board and not a new Duet. Probe feed rates. Slow, fast, K return. Slow, fast, K, so wait a second. G30Z0, yeah. Can anyone make sense of that? Probe feed rates, M607, S5, K100, R0. I guess I could just look up what M607 does. Increase slow feed rate. So it's just doing, okay, so it's just doing the slow feed rate by 2. That's M670. Oh, okay. That's basically, I guess, what Arthur is saying. Let's bump it up a bit. Maybe not that much. Maybe to, yeah, let's bump it up to 50. Whatever. And do a G30. Z minus 0.38. That was our Z offset that we did like the very first thing. So that was the very first thing we did with the original firmware. Sorry about that. That was the very first thing we did with the original Marlin installed right there. So let's just try that. Probe successful, okay. So that was a very... Wow, that is quite noisy, to be honest. Let's start it again. I mean, it does probe. It does probe. Bed's still intact. Yeah, sort of. It does successfully probe. should have, I mean, should Arthur should have just run a G30 and or 32 and see what it does. A bit noisy at low speeds. Again, that's. I don't think that is actually the fault of Smoothie itself. It's just the combination of the stepper drivers plus the motor's choice, and these are super high inductance motors. Originally, they were used for with the DRV 8825, which don't work that well with low inductance motors. They are super noisy and shit with those, and the Lego drivers that are on the Smoothieboard just work better with different motors. G32, let's do it. This is basically like the okay. Probe was not repeatable 0.03 millimeters. It was repeatable to 1.59 millimeters. Calibration failed to complete check the initial probe height and or initial height settings. Okay. Okay. At least we get a very, very clear error message, which is always something I sort of appreciate. Let's check those again. So we've got the probe height. Is that the one? Track PD, max feed rate, PD settings. For Z height. Let's just see if we. Now the thing is, if we do a G28 and then do a G30. It should tell us at what height it's triggering. Which makes absolutely no sense to me. Wait, so that's the length it's traveled. Ah, okay, now we're good. So the default firmware is telling it 360 millimeters. We are triggering at 347 already. So it's going a bit too fast now. Yeah, it's like super. It's banging hard right now. So there's our Z360. That's the only C360 we have. So let's just set it to 350 and we should be good. Good. And 607, 670C 350. Does that need a space? I don't know, let's check. It does not need a space. So let's save that and try G30, oh, 2. So it does home itself automatically. Yep, that's working. I mean, the thunk it's doing as it's slamming against the bed is quite satisfying. But unnerving, to be honest. It is a bit rough. It is a bit rough, to be honest, yeah. Calibration complete. That is nice. So what we're getting is setting delta radius to, that's actually what we want out of it. That's our length, arm length basically. Yeah. Right, so let's save those. M500. And theoretically, let's try which height we actually end up. So there's our G28. Let's do a G30 Z minus 0.38. And then we should be at a perfect height, at a perfect paper thin height at Z 0.1 or something like that. So there is this fantastic supply of calibration paper that was sent to me with the keep pressing the wrong buttons with the Atom3D. So that's what I'm going to use for this. There we go. There's our calibration paper. Yeah, too low. We are at, you know, if we check with M114, look at that. We are now actually at Z negative 0.38. That's exactly what I told the printer, because this probe does trigger once the hot end is already a bit inside the bed. So technically it does trigger too late, which is the opposite the opposite to what you get on an inductive probe. So if you move up to G0, Z0, well, let's move up to 1 and then back down. That's at 0. That should have, we're at 1. And if you actually get a side that is smooth, look at that, that's perfect. If you move down to 0.1, I don't need any paper documentation. I always prefer digital. So guys, did you see that? At 0.1 we've got the paper sliding freely. At 0 we've got it clamped down perfectly. That is perfect Z calibration basically for you right there. So that is, you know, it's just barely grabbing onto it, and my camera just crapped out again. So Z calibration is good. Z calibration is done. Crap, I'm hoping I've got another charged battery for these. Oh, okay. Ah. Thank God that one works. Right! We've got the, what should I call it? We've got the Z height set up perfectly, so at a G30 Z negative 0.38 before any print. So let's get slicing. Should we use? Let's do a Cura 2 slice. So originally we were gonna do a more extended live stream and have the Android tablet added to that, but I'm actually gonna have to move that to a different date because we are honestly just running out of time, unfortunately. Right, so Adam actually gave me wow, there we go. Actually gave me a profile for Cura 2, which is like the first time I've seen any printer manufacturer do that. So yeah, that's what we're going to be using. 0.1 sounds pretty good actually. Let's just see what I don't want to show you guys the entire directory I have here. Just one second. Let's print something. Let's print a frog. Let's print a frog. Why do I not have a tree frog? Where did I put that? Do I really have to go in and download the frog model again? There is something seriously wrong. Tree frog. Maybe add Thingiverse to that. Is the tree frog on the mark? I don't know. Tree frog, download that. Tree frog cut STL. Did I? Maybe it's already in there? I have no idea. Tree frog. Right, tree frog. There it is. Okay, so all that stuff here looks good. Looks good. Right. We do need some filament. We do need some filament before we can actually print this guy. Go. Okay. Move this another way. Now, of course, since we don't have an LCD or the Android tablet set up yet, we do sort of need to manually heat everything up, and well, I'll preheat the bed just, you know, to get that going. We do need to manually heat the hot end. We swap the filament. What is off? There we go. And the good thing about this one is that the hot end heats up extremely fast. 150, 60. So basically, we can just pull the filament out right away. Right there. Let's grab the original Atom3D red filament. Right there. So the spool holder is kind of cool, but it is way too loose, which means the smallest, you guys cannot actually see that. Okay, so the smallest movement will actually have the entire spool unwind itself. Shit. Wow, that was... why do I do these things? Why? I just snapped the filament inside the extruder. Wow. Shit. Of course I can. I mean, yeah. Turns out the extruder direction is actually still what? Okay, extruder direction is inverted. Which I don't think we can change easily right now. All right, guys. Unfortunately, we are not going to get a print out of this one right now. The motor is still inverted, so it's turning the wrong way around. I should have checked that before. When I look straight into the camera for a second, should I look straight into the camera for a second? So that would mean we'd have to go back into the config, do all that, and I'm really not feeling like that. So I think we got a whole lot done today. We got the smoothie in, we've got the smoothie board working. There's just, you know, a bit more to configure. I know it's like not completely unsatisfying to have the stream end with nothing printed, but that's just gonna have to do it for me for today. Like I said, I first would like to set up the auto mesh bed leveling and you know, have the extruder properly configured, and maybe look into why this thing is still so loud. But yeah. But anyways, thanks everyone for being here. Thanks for coming along. There is going to be a part 2, as much of that sucks, I know. There is going to be a part 2 where we actually take like the last few steps, the last few fine-tuning steps, and actually add the Android tablet to this printer. I know that it was on the thumbnail, but it's live, so I can't really predict what's going to happen. Nobody else can really predict what's going to happen, so that's just what you get to roll with. All right, it's 6:45 for me p.m. Yeah, 8 p.m. is going to be the Patreon hangout. I'm going to grab something real to eat. I'm going to drink something, and yeah. For those of you who are supporting me on Patreon, thanks for that, and I see you in a bit over an hour. And for everyone else, thanks for being here. Maybe check out that Patreon campaign, and you can join in too. But again, thanks for being here. Thanks for watching. I will start looking for the right button to end this stream, and yeah, that's about it. Like I said, tomorrow is going to be the if I get it edited by then. The Prusa i3 Mark II review. That is an awesome machine, so look forward to that one, and I'll see you then, I guess. Bye bye.